first and foremost, I want to thank everybody's support to this project, and we appreciate the continuous contribution and input to this project. We really need your feedback and the involvement, more importantly, feedback and involvement to this project. As you know, part of our pool fund is to develop the actual specifications. So I want to make these specifications works for everybody and also implementable. So we do want your engagement and involvement and feedback to this to our study. As Kyle stated in his email, today's meeting will be focusing on the sharing experience and the data collection and analysis. As you probably recall, in the last October meeting, we encouraged the states to go out to, if you have opportunity, to go out to collect the data following those draft procedures and send it out in the last spring. One is for the field data collection, another one is for the laboratory part calibration. Then we come back this spring, which is today, to review the data collected and also share the experience among each other. So with that in mind, we'll want this meeting to be interactive as possible. And so we can get your feedback instantaneously and hear your criticism or improvement we should make in these procedures and also data analysis part 2. So if you have any questions, suggestions, or any criticisms, just jump in and talk. And in this way, I think we'll probably make this meeting more productive and constructive, and we can learn from each other more effectively. Before I hand it in to Steve, and I just want to give a brief overview and the project status. Let me share my screen and this. Oh no, that's not the one.
Yeah, and while that's pulling up the screen, I just wanted to reiterate the more involvement today, the more successful we'll be, and it's supposed to be as free-flowing conversation as possible. There's not vendors, so feel free to talk about improvements on the technology and stuff that you'd like to see. We'd really like to get as much feedback as possible from the group.
Yeah, that's why I want to set a free discussion forum so everybody can have participation in the end of this meeting. Can you see my screen now, everyone?
Yeah, can you use presentation mode, Dai?
Okay, thank you. Okay, so I want to give a brief update on the overall project status before I give to Steve. As you know, we have 7 tasks in our work plan, and I talked the details of each task last October. So I just want to give a quick overview on the status of each task. For the task 1 is software and hardware improvements. So we'll have a contract in place with the GSSI to primarily modify the software and improve the software. And due to the pandemic effects, and the GSSI has some delay on the contract, so we extended the contract to the end of this year, end of December of this year. But majority work. Yes, questions? Oh, sorry. If any, please mute your mic. So if you're not talking. Okay, so majority work are done, and excuse me. As of now, 6 out of 10 tasks are done. Excuse me. They're planning to get another task done by the end of June. So also the planning have 2 new releases of software. One is end of April, another is end of June. And we confirmed with GSSI, and participant states in this pool fund will get free version of this new releases of software. That's good news. And from hardware side, we obtained the PaveScan 2.0. I believe most states should have the 2.0 right now. And we evaluated this device last summer and through the fall and the project. So one thing we happened to us is when the Mercedes took out the DPAs from the vehicle, all of a sudden the one arm fell off from the frame and the connection broken. So GSSI fixed this the ARM issue, and since then we have not had any problem. So it worked very well for us so far. And software, we evaluated the software, and Mercedes has done a great job and documented the issues and the bugs on the site, and communicated with GSSI to make improvement on the software. So you will see that's some new features in the software when you get the new release in April. Certainly part calibration kit. I think some states already got the part calibration kit. And another new feature in the software is the playback range. That is very good feature. So right now you can use the software on the side to view the joint, the mat joint density versus the mat density versus joint density. You can compare this density on the side. And also you can select the part of payments, and then you can select from this station to that station to view the data collected. It's very handy feature for the field people. And for task 2, that's the development of actual specifications. Like I mentioned before, we draft up the part calibration and the field data collection procedure last spring, and also will produce the training videos, and that was based on a 1.0 device. And since we got 2.0, then we updated this video portion and the laboratory calibration portion and a few weeks ago. And the video is uploaded into the DPS website, and this is the address. So you can go there to view this calibration video, the part calibration video. We also plan to update the field data collection video and the update these procedures using 2.0 device by the end of the May. By that time, we should be able to get on the field and to collect the data. From data collection perspective, we continue to hire the contractor to collect data for us. For this year, we are going to try a new program called the pay for the data program versus the pay for the hour. Previously, we just paid the contractor by the time to spend it on collecting data for us. But starting from this year, we're going to tell contractor to get equipment by yourself, and also we'll pay the amount of data, and we'll give you a spec and the data format spec, and you need to follow this spec to collect the data for us. Then we'll pay the amount of data you gave to us. Instead, we'll pay the hours, the time you spend on collecting data. And previously also loaned them equipment, but from this year, we're going to tell them to get equipment by yourself, either through rent or buy by yourself. And the encouraging things to us is one of our local contractors already bought equipment, so they're playing around by themselves right now. That's very encouraging to us. And from task 3 and 4, that's precision bias statement development and equipment operator certification procedure development. So we'll have a contract in place with NCAT to work on these 2 tasks. The contract was fully executed at the end of December of last year. And Dr. Fabrizio Leva is here today and to give detailed descriptions of the testing plan. One thing I want to mention is the round-robin testing. And in order to establish this precision bias statement for the laboratory part calibration procedure, so we need to conduct the round-robin testing. And he will be contacting the states and hopefully get your help and help him to do this round-robin testing. For the task 5 is support communication, and that's ongoing effort. Right now we have a monthly meeting with Federal Highway to exchange the information and the research results. And Federal Highway has its own program to evaluate the DPS system. So we have set up a monthly meeting to exchange information with them. I know Carl has been providing the online communication or support with some states, but we will continue to do so. If you have any help needs, just let us know, and we can get online very easy nowadays. And we're still planning on face-to-face meeting either this fall or next spring. And we want to bring you to the Minnesota and particularly look at this DPS data collection device. One is the Gator data collection, and another is robot data collection device. Hopefully by that time the robot is going to work. For Tech 6, it's also ongoing effort to provide technical training and assistance to states. And like I mentioned before, Cal has been providing some assistance to some states, and will still continue to do so. And also in our work plan, we'll have certain funds set available for the on-site training if you need, and just let us know. And assuming we can travel sometime late this year or next year. And also another good resources for training is the Federal Highways Mobile Lab. They have 3 DPS devices right now, and also they're getting another one from my understanding from talking to Steve. So they're going to provide the trainings and also loan program to the states, and that's another very good resource of training. In terms of Task 7, promoting technology, and the Craig and Rich and gave the very excellent presentation at the Federal Highways DPS 101 workshop last week, and we'll also give a presentation the next week and the week of following next week. And Federal Highways Mobile Lab loan program is very good promotion method, technology, the mechanism for the promoting this DPS system. And also we have been giving presentations at different meetings, internal meetings, like the bi-weekly procurement meetings and MEO meetings. And also by hiring the contractor, collecting data for us, and that's another way to promoting this technology to the contractor. And from what feedback we got from contractor right now, they're excited about this technology so far. So also we still need to make a brochure as part of this project. And the last, I just want to quickly share with you the activity we're working on by ourselves. This is beyond the pool fund. If you were in the last week's meeting, I shared with you these 2 DPS data acquisition device. We're putting the DPS into the gator, so we'll let the gator drive on the people drive the gator on the road straightforward. We'll set up these 2 sensors and move back and forth from left to right to get the full coverage and the payments. And also this sensor can be movable too, also can be stay stationary to measure the longitudinal joint compaction. And we're working with the University of Minnesota to make this DPS as a robot DPS system. So eventually we want the computer to control the robot and to get the full coverage and the payment surface. In terms of funding perspective, and we're still in good shape of funding. We'll have $450,000 left, something about that. I just got this one from our research services financial people last week. So that's all I have now. Any questions for me at this point? Well, if not, then I will pass to hand it to Steve. Steve, can you take away?
Yeah, can you hear me all right, Di?
Yeah, I can hear you.
Yeah. Okay, yeah. So Kyle asked for a quick update on what Federal Highway has been pursuing in the near future. I think first, hopefully most of you know Federal Highway. We have a support contract with QES to support DPS activities. The last major event they hosted was a DPS peer exchange at TRB last year. So the next activity was to support a DPS implementation planning workshop, and we were kind of putting this on hold for a while we deal with this pandemic, but we finally decided to have this virtually. So it is scheduled now virtually for April 20th and the 21st, and I know a few of the agencies on the call today were invited for that event. Some of you might have remembered during the SHARP 2 Implementation Assistance Program for R06C, we had an initial implementation planning workshop. It was early 2014, but at the time it was focused on the 2 technologies, the infrared technology, which is now the paper monothermal profiler, and also the DPS technology. But really the most of that implementation planning was focused on the infrared, just because that was a technology ready to go. Not so much on the DPS, although we saw a lot of potential benefits for this technology. So since then, Minnesota, supported by a number of your agencies and industry, you're making quite a bit of progress in advancing this technology and addressing the initial challenges. And there's been a lot of improvements. So what we want to do is April 20th and the 21st is meet again and take a deeper dive on implementation planning on just the DPS technology, with the goal of having this as a viable materials acceptance alternative for measuring density. So with stakeholder feedback, we'd like to identify the gaps that can hinder implementation, discuss specification needs, discuss what's needed to use it for acceptance, and also what federal highway requirements are, and also additional research, and hopefully talk about data analysis and data processing. So I'm curious to hear what you guys have to say today. And lastly, we want to talk about opportunities and strategies for successful implementation. And that includes other benefits for this technology, contractor quality control, process control, forensic opportunities. So the outcome is QES will provide a plan, a DPS implementation plan, roadmap of sorts that should help us in the future and give us some direction. So Di talked about the 90-minute webinar we did in preparation for this, March 31st. We called it DPS 101. So Di and Kyle have all the presentations and the recording, and I think they're going to post that on their site.
Correct, yep.
And it should be good information to help you educate your agencies on the benefits of the technology. So please take advantage of that. And then Di also mentioned a little bit about Federal Highway. I mean, we're still a strong partner here. We're assisting Minnesota and our stakeholders as much as possible. And that includes supporting research, demonstrations, and potential implementation. So we do have a DPS cart at Turner Fairbank. So we are in a very good position to support research. As Di said, the Mobile Asphalt Technology Center, we do have a small handful of carts right now, so we can support equipment loaning and demonstrations if you need it. Right now, even with the pandemic, we were able to loan Missouri and South Carolina carts and provide them training. And I think on the waiting list, we have Arizona, Massachusetts, and Wisconsin. And Massachusetts wants both the infrared and DPS technology. We have both for loan and demonstrations if you're interested. So that's all. Quick update. Thank you.
Well, thanks a lot, Steve. So, and thanks for a great introduction, Di. As Di said, I want to just reiterate before I get into my presentation. We are close to 50 participants right now, but we would like to try to allow you guys to feel free, if you're comfortable, to just step in with any questions you have. Any sort of discussion generated here, I think, is what's going to be the most valuable for us. And if you're more comfortable in the chat box, that's fine too. We'll continue to monitor that as it goes. And one question was about slides, if they're going to be shared, and they will be posted to our DPS Pooled Fund website. So with that, I'm going to get into my presentation here, and we were going to start talking about the new 2.0 puck testing kits. Can somebody just give me an affirmative that you can see my slides?
Yep.
All right, thank you.
Yeah, yes, I can see it. Yep.
Yeah, so we're really excited about the puck testing kits, and we're hoping to get as many other pooled fund states and other agencies using them. One great part about the new setup is really the only thing you need is the antenna, one antenna from the existing sensor. And for those of you who use the 1.0 for puck testing, it was a bit of a process trying to tear down your field testing unit to be able to get those puck tests. So that's a really good thing for us. I wanted to mention that we get a puck calibration HDPE puck, which is really nice to make sure the sensor is working properly. And as I said, it's really convenient to keep right in the lab. And what we found, we were able to get our hands on one at the end of last construction season, we just shoot it for the dielectric value before it even gets dunked in the water. So if you have one of these kits on site where the production mix is being made, it's pretty quick to just get your dielectric measurement. And then as soon as you measure the air void content, you have your correlation between dielectric and air voids. One thing I wanted to mention that we got some feedback from states with bias between lab correlation and what we see in the field. And we're looking at numerous things to address this. And one of them that we're on right now is just really the importance of getting a precise height. So please, when you're doing these puck tests, as we say in the fabrication video, what we're advocating right now is to use the gyratory compactor readout as your puck thickness. It's the most accurate, we think, for the height of the puck itself. With a caliper, it's just a little bit too sensitive to pressure, and depending on who's doing it, you can get different readouts. And the reason that's important is even as little as a millimeter error is almost a full tenth of a dielectric, which corresponds to a full % air voids for most mixes. So that's one thing, remembering to use the readout from your gyratory compactor for the height. And then we're also in the lower right corner, you can see a puck thickness measuring device, and we're going to do some in-house testing with that just to make sure that this gyratory readout is a good way to go. And then also it's good to have a way of checking to make sure that the gyratory compactors are calibrated, which I believe most states they're required to be. So more to come on that. One thing that's really nice, as you can see in the upper right corner with the old system, really, if you didn't put information in the file name, you had no idea where the measurement came from. So we wanted to address that, and we have both project level groups and file level inputs. And the goal here is to match your QA/QC tracking information that you do for all your material on a project. And the nice part about these inputs is you just fill it in once, and unless it changes, you just leave it there, and then it's tied to your information. And you can choose to track it within the PaveScan software or leave it blank and track it elsewhere. But I think you'll find just keeping everything self-contained in the puck kit software is going to be the way to go. And one thing I'll mention, if you don't get everything I'm saying during this presentation, we do have a video I'll be referencing later that takes us through the whole process of getting these tests done with the puck testing kit. Another thing I'll mention right now is we're advocating doing a top rotate 90 degrees and bottom test with the puck, just to make sure that there's no effects of where you are on the puck in case there's some sort of a compaction gradient within the sample itself. But again, that's in the video to keep your eye out for that. And then also one thing we found with this new puck testing kit, for those of you who did the first 1.0 version, you kind of had to be a ninja a little bit with the samples and make sure you got everything flipped and switched and changed within a certain 5-second time window. And that, of course, leaves a lot of room for error. And with this new puck testing kit, it's very simple. You know exactly which step you're on. You start with the background pictured on the lower left, work to the metal plate, then you do the surface measurement, and then the surface plus metal. And the contractor who used this was very complimentary of how the software worked and how intuitive it was. So that was good news to hear back from the contractor. Another thing that's really nice is circled or squared here in green is that you actually get a dielectric readout right away. So with the HDPE, you'll know whether you're within the 2.32 to 2.38 range right away and whether or not your sensor is in spec. One thing I wanted to highlight based on our initial experience is that the first HDPE measurement, for whatever reason, tends to be a little high, but then the next two, it levels off. So keep your eyes out for that. We talked to GSSI about it, the vendor of this puck kit, and they confirmed that they've seen that too. And as of now, there's not necessarily a rhyme or reason why that occurs. So if we continue to see that, we may want to just say to not use the first test as representative, because the next ones hit spot on. We've also observed very great precision with the new puck testing kit, typically within 0.03, and that's actually quite abnormal if it's even off from 0.03 or more if you're doing a measurement on the same specimen. Even if you're doing on the top, rotating 90 degrees or bottom, we're getting very repeatable results, which is a nice thing to see. And you'll see these red X's every once in a while in this presentation. It's basically just giving a sigh of relief and moving on from the old system, which in a lot of cases was not set up to do this test very efficiently. So with data export, that's a huge improvement. We actually get the results tabulated within the software itself. And if you remember, MnDOT had created these MATLAB executables that you had to export the raw data and follow all these different procedures just to get a result. So we wanted to highlight that within this puck testing kit, you do have a real-time result that's tabulated for your dielectric, and then as soon as you measure the air voids, you can actually go in there and update your table that way. With the data input and organization, everything's labeled. So you see the finger pointing to the 4.4 air voids. That's what you do once you get done dunking the specimen and doing your T166 or core lock measurements to get your voids. You can input it directly into the software, and that way everything is stored and can be exported directly from the puck testing kit. And again, no more executables on the processing. You have the results already to go. And in this case, once you go into your specific test, you just take the calibration results for a linear correlation between dielectric and air voids, and you should be ready to go with your field testing kit to be measuring directly outputting your voids percentage or percent compaction, whatever you prefer. And this can either be done directly in the software to get the correlation coefficients, or we will provide a little template we've built in Excel, where basically if it's green, that means you can paste data. So in this lower corner is your puck results. And then later you'll see when you paste the field results, it tells you how good your fit is matching to the actual field cores that we're currently advocating that you take to ensure the accuracy of your conversion. And again, it's just a simple copy and paste from the exported file that of course contains all the information you input for that specific project, which we think is a good way to make sure we're tracking everything right. I put a picture of Oprah saying, "You get a car, you get a car, everyone gets a car," because, well, I always wanted to do that. But in this case, you guys don't all get a car, I'm sorry, but you do get a puck testing kit if you're part of the pooled fund. And the only thing the vendor asked is that you share all the data that you collect. So from our information, we believe, all these different states, Maine, North Dakota, Ohio, Alaska, Idaho, New York, and of course, Minnesota, we have our puck kits. But if you are part of the pooled fund and you have a system, please inquire with us or directly with GSSI, because they did let us know that they're willing to share the puck testing kits with the pooled fund to try to get this technology moving and do this coreless calibration with the technology. And lastly, I wanted to summarize some thoughts and then also play a little bit of the video, training video, and this is where you can go for the more detailed information. And please give us feedback, because we have a Camtasia software that allows us to do different editing with our training video, but you can jump to different spots. If you're more interested in the test itself, you can do that. And just in general with this puck testing kit, we think it's a lot more user-friendly. One way to say it is there's less opportunity to screw it up. And then, of course, you get real-time feedback, which is important. So with that, I think, again, I'd like to make sure everyone knows that they can ask questions if they have any, or
if
put
any
it in the
questions,
chat box.
just jump in or comments. Any questions or comments, and for the Kyle's presentation, jump in anytime. Next video again is on our website, in the Pavement website. You can watch the full video. There's the previous videos too, and also this DPS, this Gator type data collection vehicle. The Gator is also in the website.
Hey, real quick, hey Kyle, this is Matt Oman here. So do you just plug a single sensor into the computer and just circumvent the whole cart, or is there anything?
That is correct. Yep, with the puck testing kit, the only thing from the actual field testing cart is a sensor itself. Okay. The cables and everything else is, and then you have to have a tablet or a computer that has an Ethernet port too.
Okay, thanks.
Yep.
Well, our next presenter is the Dr. Leva from NCAD, and she's going to present the detailed work plan for the task 3 and 4. Dr. Leva.
Good morning. Can you see my screen, my presentation?
I did for a little bit there. Can you share it again?
All right, let me see.
Yep, we can see it.
All right. So again, good morning, and I'll present part of the agreement that we had with Mindo with regards to the pool fund. My name is Fabricio Oliva, and I work for NCAD. I wanted to share a little bit of the motivation, or part of the motivation that led me to work with this project. And basically, this was an example that Kyle was able to share with some of you in the past. And basically, here you can see how there was a low spot or low density spot that was detected by the use of this technology. Otherwise, with the conventional quality control, quality assurance process, that wouldn't be the case. So I think that's something to keep in mind, that having, and only if we only had one profile of density, that could have been enough for this project. And again, I wanted to emphasize that having that advantage of doesn't have to be full coverage. It has to be at least something that can show us that the density changes with distance, and that's something that we know, and we want to take advantage by using this type of technology. And again, as I mentioned, this was also collaborated later on, or verified later on, by checking all the different density results, and what I said before, the standard QA practice did not capture this low density spot, and that's something that we can take advantage at this point. We can take action immediately and come up with solutions right away, instead of waiting a couple of days, if you're lucky to find that was a defective area. All right, with regards to what we're planning to do with this project, the objective is to further advance and improve DPS technology. And that's gonna take advantage of ASH2 specifications developments. In that case, NCAD has extensive experience with equipment and operator certifications, specifically to the profile certification that we currently have at our test track facility. And the idea is also to use that DPS technology for data collection and analysis of different methods. We also want to conduct this round-robin test and develop precision and bias statement for those results. We also plan to support any type of communication, participating in these meetings, workshops that are programmed in the near future. We also want to help in any type of training and technical assistance to states and others, and continue promoting this type of technology and marketing. So specifically for what we have planned for the NCAT DPS experiment, we're going to take advantage of reconstruction that is going to happen in August, September this year. And since we're going to have several new sections, primarily we'll have new full depth sections that we call the additive group experiment. At this point, we're going to have 6 new sections that are going to have 5 inches total of asphalt concrete on top of 6 inches of granule base. And those are going to have pretty much new materials, ranging from plastic, rubber, fibers. So that's going to be, I think, something that we would like to explore. Having this already in a location that we can have all these different technologies in one place. So we're going to be able to evaluate all of them, at the same time. In addition to these sections, we are expecting another 8 to 10 mill and fill sections from using different materials. So we're going to take advantage and test every single layer that we have there. With regards to a specific task, the first one is pavement thickness effects on DPS measurements. And here, what we want to do is evaluate thin layers and thick layers and see how the results come back in regards to dielectric constant. The original plan is to compact several slabs and then place them on top of concrete, asphalt concrete, and we also have steel that we're going to use to test those different slabs. At this point, we have plans for 18 by 18 slabs, and later on we're going to repeat this process with the identified sections. Since I mentioned before, we're going to have sections ranging from 5 inches total in thickness. By the way, these are going to be placed in one lift. So we're going to have 5 inches all the way down to 1 inch at the track. So we're going to be able to separate, again, thin and thick layers at the track as well. And we already started the process of building or creating these slabs. We can do 1 slab per day. And the process at the beginning is going to take a few slabs. We're going to test extreme values in regards to thickness and density. As you can see here, the lab testing plan was to have 2 different mixes. One is a 9.5 millimeter nominal maximum size, and the other one is a 19 millimeter maximum size or nominal maximum size. And the plan at the beginning was to have 4 different density levels ranging from 88 to 97% of a GMM. But at this point, we're going to try to start with extreme values from 88% to 97%. And we're going to have those 2 mixes with slabs ranging from 1 inch to 3 inches for the 9.5 millimeter and a minimum of 2 inches to 4 inches for the 19 millimeter. And that's basically, trying to comply with the thickness to nominal maximum size ratio. So we don't want to go too low, so it's going to be difficult to compact, or we don't want to go too high, which may come up with different effects. So that's pretty much task 1. Task 2 has to deal with equipment and operator certification, and here we're going to try to reproduce what we have in place with regards to profiling systems. The idea is to come up with a parallel practice to AASHTO R5614, and develop all the different repeatability and accuracy scores, or something similar. So the plan is to have the electric data collection. We're going to have 3 different baselines that we're going to collect with a electric density gauge. We also have a nuclear gauge available, so we can go, and the plan is to go in intervals of intervals of 1 foot on all 3 lines. And we can utilize both. Of course, the nuclear gauge is significantly slower to operate, and we're at this point we're probably gonna go with the electric gauge. And then the plan is to obtain 10 replicates per antenna with regards to the DPS device, and that is gonna help us develop, as I said before, repeatability and accuracy scores that later on can be used to test on other devices, other DPS devices. And I say at this point it's going to be 10, at least 10 replicates. It can go, 15. It can go 20 until we get representative and statistically sound profiles, so we can say that we are confident that the scores are going to work for any future device. All right, and we're going to follow some, as I said, something similar to R56. So we're going to conduct a cross-correlation analysis to develop those scores. And for the moment, we have selected 4 different sections that were constructed a couple of years ago in our test track facility. And those sections are part of a Florida DOT experiment to evaluate effect of density on cracking and durability. And at the beginning, those 4 sections were meant to have density levels ranging from 88% to a little over 94%. And here you can see a correlation between this electric gauge and core density. And those were the cores were taken at the beginning of construction, and then there's another set to have 8 total. The second set was taken 1 year after, and this is pretty much what I'm showing here is the correlation between the core density and that gauge density, and the idea is to use this correlation to have the entire density profile using this device, and then that's gonna serve as a baseline to conduct the cross correlation analysis. Right. With regards to task 3, we're gonna work on development of precision and bias statements for the pucks that are created in the lab. As Kyle was mentioned, we're gonna hopefully use that new kit to evaluate or to come up with the relationship between a specific gravity and dielectric using that advantage of that new kit. And the plan is to have one set of cores or pucks. We're gonna create those here at NCAT, and then we're gonna ship those out to different labs. So every lab is gonna have the same set of pucks to test on. So we're gonna use ASTM A691, which is the standard practice for conducting this type of studies and to determine precision and bias statements. And from here, we're gonna develop repeatability and reproducibility results or criteria. At this point, we are looking for minimum 6 labs. Ideally, we'll have 9 to have the entire matrix to come up with these values. One thing we discussed with Kyle and Dr. Dye is to maybe use one antenna as one lab, and that's something that we can do. But we'll still need to find a couple more labs at least to have more data. At this point, it's going to be NCAT, MinDOT, and we're looking for a third one or fourth one to conduct this type of study, or to help us with the study.
And Dr. Leva,
Yes.
we got a really good question in the chat here that I'd like you to address.
Sure.
Yep. Ulrich said, question for Leva. I noticed that there's no plan for testing 3/4 inch thickness. Do you think that we could apply the result to a 3/4 inch pavement after your results?
3/4 inch. I'm sorry. Can I read that?
Yeah, I think he's referring to the slabs, and specifically addressing if there's going to be underlying effects on thin lifts that may be placed on a material with a different dielectric.
Yeah, I guess the 3/4 is the thickness of the slab. Yeah, the minimum at this point is going to be 1 inch, and that's basically just to respect the thickness to nominal maximum size ratio. We don't want to go below, or at least keep or stay within that value, because that probably is not going to be realistic, in my opinion, in the field. Based on our discussions, we were suggesting that most of the overlays are in the range of 1.5 to 2 inches of overlay. That's pretty typical. But again, it's going to depend of the size of the nominal size of the mix. And again, yes, I agree that thin lays, are at this point are difficult to measure that density, even with the nuclear gauge, the one that is only or is set for only thin lays. But that's something that not only for density is a limitation. If we want to obtain all the properties like back calculated moduli, that's another issue as well. So all those for thin lays are unfortunately difficult properties to obtain.
I just want to add, so our experience on this minimum thickness lift, our feeling is about 1.5 inches. And so anything less than 1.5 inches, you would get some maybe underlying layer effects. That's from our past experience, and we did a little bit of calculation that too. We just want to do this confirm. So if inch lift thickness is going to get affected by the underlying layer, then for sure the 3/4 inches is not going to work. So we're going to try this inch first, and our feeling maybe we'll get the effect on from underlying layer.
Yeah, and Fabricio, correct me if I'm wrong, but we could potentially be open to going below if, for example, we do our test on 1 inch thick and we don't see an underlying effect. If we do see an underlying effect at 1 inch, of course, the 3/4 inch will also have an issue. Or is there a limitation in terms of being able to even fabricate a 3/4 inch slab with the necessary constructability, I guess? Have you ever tried that thin of a slab, I guess?
Yes, yeah. In that case, we will have to go and select an 475 or number 4, nominal maximum size mix. So
yep.
we will have to go one mix below, and
yep.
we should be able to create a 3/4 mix.
So Ulrich, if that's a big need for you and anybody else in the pooled fund, I would think we can discuss it with Dr. Leva, and hopefully we can address that as an important factor to know about the device, especially considering, as Dr. Leva said, there's really not a great way to measure thin lifts already. So it would be a very useful aspect of the technology if we could in fact measure those thin lifts. And the second factor that always plays into this is the layer below the thin lift. So if it's a similar dielectric, that will be much less likely to affect our dielectric measurement than if it's a different dielectric material such as PCC or something like that.
Yes, I was asking the question because here in Maine we do have a lot of pavement with 3/4 inch overlay. Mm-hmm. And we don't have density requirement for those type of pavement. So we wanted to see if there is any effect of that thickness, if we can measure the density, the dielectric to be able to analyze the uniformity of the compaction. So that was something we were looking into. So
very good. Yeah, and another thing to add is that we do have some data collected that hasn't been analyzed yet for the effective underlying layer at Min Road, where a 3-inch lift was gradually changed to nothing at a transition zone. So hopefully we'll be able to provide a little insight to support Dr. Leva's effort there too.
Okay, great.
All right. So continue with that with task 3. Again, the plan is to use those same two mix types, a 9.5 and 19 millimeter, and also use the same density levels ranging from 88 to 97%. One question I wanted to ask to the participant is that we may want to use core look from the beginning. As Kyle was mentioning before, we will plan to measure the electric before dunking those samples in water. But if we were to use core look, that we may be able to preserve that or avoid adding water to the pucks. So that's something we're probably gonna do. We're gonna use core look for the samples that we're gonna distribute among all the different labs. So we don't, of course, we want to know the specific gravity of those pucks, but at the same time, we don't want to add water to those. So I think at this point, core look is the way to go. And later on, we're gonna move on to field testing, and we're gonna come back again with several sections where we're gonna take cores, and we're gonna compare what is the effect of moving from a lab compacted samples to cores, and we already have an idea based on several conversations and meetings with MinDOT that there's an effect. We would like to see what is going to be the effect on those statements when we move from lab compacted samples to cores. And at the end, as a summary, I wanted to share with you the deliverables that we plan to provide to MinDOT for this full fund study. And I think the bias and precision statements are some of the importance if we want to have an idea of the overall variability of the equipment when we are evaluating lab compacted samples. We're going to be providing support and evaluation of testing variables in the lab and in the field. Of course, all those results are going to be available for you guys, and we're going to continue sharing those results. Equipment and operator certification and standard practice. With that, we have a couple of students that are going to help us to provide a standalone software. Basically, on MATLAB, we should be able to create standalone software similar to what we have in terms of inertia profiles. So once a contractor or a vendor comes with a new DPS technology, we should be able to input all those different profiles, compare those to the baseline profile, and of course, there has to be a cross correlation among the different profiles, and then we should be able to come up with a score and compare that score against the standard or the criteria that was set from this study. And at the last, we are already helping in communication and promotion of this technology, and we should see soon an NCAT newsletter where I discuss and try to promote a little bit more this technology.
Very good. Thank you.
Thank you. And any questions or additional questions or comments?
Any more questions for Dr. Leva? Okay, thank you, Dr. Leva. And then Thomas came from New York is going to share their experience on the data analysis and the collection Tom has been very helpful and the pool fund, and we can continue to constantly communicate with them and this data analysis and the procedure. Tom, are you online?
Yeah, Dai, how are you guys?
Pretty good, thank you. How are you?
Good.
Good. Let me just pull up my screen. Everybody see that?
Yes.
Yes.
Excellent. So 2020 was the first year that we piloted the rolling density meter. We did it a little differently than I think some of the other states on the call. We don't actually own a meter yet. It's coming. The GPR is in the mail, if you will. We actually put the language in the contract for some paving work we had in 2020, 5 projects specifically, and we had one of our really proactive, forward-thinking testing firms, Advanced Testing, actually purchased a unit and did the testing. It was really good for us because I don't necessarily know if we had the manpower and the availability last year to do all of this ourselves. So we had a really good partner with Advanced. So a lot of this data that we're going to talk about and I'm going to go through came from them, but obviously we were working with them quite a bit through the season. We had 5 jobs scheduled last season. Only 3 went. You know, we ran out of calendar a little bit. But these slides and this presentation that I'm going to go through with everybody right now is what I shared with both some of our regional construction people who have asked for it and our regional materials engineers. So some of these slides, it is going to be very much not news to anybody on this meeting, but I left them in just because I think it was important to understand how we're kind of promoting it within the region or explaining it within our regions of the state. I felt like we had to talk about the RDM in terms of what we're doing now for quality assurance testing for density monitoring. The cores obviously is the gold standard, but the cores just generate all the problems from destructive testing to trying to get the tests performed, to questions, and we're still getting them infrequently. The gauge obviously lines up a lot closer to the RDM, but I'm really trying to get these guys to appreciate what that data from the RDM can do when compared to the gauge. Obviously, it's a similar technology with a source and a detection, and we just spoke about this in the last presentation with some interference from below, but the gauge obviously also, the results from the gauge, I should say, the lower lifts do contribute to those results. There's other problems with the gauge too. Right now, all of our gauge data is generated on a paper form, which means somebody's doing math in the background to figure out our running averages. There's always the ability for a guy to move a gauge reading to the left or right. So I really want to introduce to some of our construction staff that while everybody's familiar with the gauge has its limitations and has its own set of issues. Really basic primer for these guys, just to understand that much like the nuke gauge, this is a transmitter receiver type scenario. Really basic right there. The other thing to really tell our construction people were some of them who have been exposed to GPR technology in the past and GPR results, this is what they see and somebody hands them this and they go, what the hell am I going to do with this? I think it's really important to differentiate some of the GPR output from more geotechnical applications and structural applications than what we're talking about here with the RDM. Rolling right into that thought, this is, I think, what grabs a lot of contractors and the engineer's attention, is that this is the result that we're getting from rolling over it. It's not going to look like that black and white kind of Rorschach test of interpretation. You get a color, you get a yes or no. This is something that I think a lot of the EICs that we were out with this year were really taken by. And this is something that you can really use to kind of promote the concept. And I'll say that from both our engineers' perspective, our regional materials guys are very progressive. And even a lot of the contractors, they see this, they see the bright colors, and I swear to you, it almost sells itself. There's a lot of interest in where we're at. Kind of jumping ahead of how we put it into contracts this year, like I said, we ended up doing 3 last year. we took a range. Let me start over. This got inserted into two different contracting mechanisms, but our process was still the same. We still asked for the gyratory specimens compacted at anywhere from 86 to 98. I don't think we necessarily needed to be doing that, but for the first year to get this in a contract and get some exposure to it, we figured why not ask for a little bit more. Going through with the puck kit, obviously the first time, but this is also to more or less, this slide, when I presented it to our regional staff, was to basically promote that there is a measurement going on, that those colors that you see on the screen are being derived from something. They don't typically see this, but it's important, I think, for them to know that there is a tie-in. And this is just another kind of slide just to demonstrate that the gyratory specimens that we're asking for really are fitting into that linear range of expectations. So here's kind of the first slide of data. This was our first project. This was taken outside of Utica. And first experiment with using the puck measurements, we had some flyers. The slide to your left shows all the data that we had. The slide to the right shows it excluding those 4 points. I really can't explain those 4 points. This is going to be a common theme with some of the other data that we're going to talk about, or I'm going to present today. I'm not really sure why it happened, but it's pretty clear that there was a flyer there for whatever reason. But excluding it, we really get a good correlation with those pucks. When we did our data collection, just a couple of things. Obviously, we did all of our cores with the center sensor. However, we did 2 passes at 1, 3, 5, 7, 9, and 11, plus or minus, down the core. So we're getting 6 lines of data. And we'll talk about that a little bit more in a second. But here's the beginning of what the data was. And the core is always going to be shown in pink, and we'll show that on the graphs as well. And then the blue will be the radar information, the orange, the nuke gauge. I still have everybody?
Yep.
Sorry about that.
Yeah, we're here. Yep.
On this first project, we also had some binder data. The binder data, as you can see here under this delta RDM, we were a little bit all over the place on that first day of data. I think some of our data may have been skewed by minor production changes at the plant. The plant, this specification that we ran on these contracts ran in the background. So meaning this was just a shadow program to collect data. Their pay and their incentive payments are still based on volumetrics. So there still was an incentive, even though that we asked them to not move the targets. Obviously, there's a financial incentive for them to ensure that they are going to get the most incentive payment they can. So there was slight movements. I don't know if that played a role here, but it is a possibility. Graphically, you can kind of see this a little differently. Pretty tight though. Our binder data actually looked reasonable, I'll say, particularly for our first day, our first project. The 9.5 data, I think there was even more production changes on this one. As you can see, that column of delta RDM right here really was quite high. You know, we're getting at one point 135 for an average on the RDM, 145 on our cores. So this is significant. It does seem to trend, as you can see with the data a little bit. The RDM data seems to be consistently lower. The nuke gauge and the cores obviously are a little bit closer, but whatever the reason was here, it was pretty consistent. The longitudinal cores were really the interesting one on this first project. I highlighted the ones in red where we see the delta RDM, and I apologize. It's a lot of data. I don't expect everybody to really be able to take it all in. but we had some really, really, really poor values on these. The standard deviation was kind of all over the place early on. Seemed to kind of come down as you get down to the bottom of the page here. It seems like we've kind of got them together. It was a little bit tighter. Our deltas were looking pretty good, but then we would occasionally still get these flyers. It's important to note too that we also had some big deltas with the nuke gauge on the longitudinal joint as well. I think as we move to this season's work, the longitudinal cores is something that we're going to look a lot more at. This was the only project where we had longitudinal cores in a longitudinal measurement for, but there's a lot here to unpack.
Tom, question.
Yes,
Tom,
sure.
So did you longitudinal join the core? Did you core through the joint, or did you take a little bit away from joint?
It's a little bit away. A little bit away. So we're primarily using wedge joints, so we're trying to get the meaty part of that wedge.
Okay, similar to ours.
Yep.
Okay.
So just more scatter. I think when you plot it, things kind of pop up, but you definitely see that we're a little more variable, definitely early on. But the one thing I want to keep coming back to is that this was our first shot. This was our first project out of the gate. I'd like to think of it, I mean, I had 2 little kids. Christmas morning, there's nobody stopping to read instructions. Everybody just wants to go out and kind of take it for a spin. And we definitely learned some things the hard way. So I think you'll see our data accuracy and our delivery a little bit better as we go on here. The next project, we got considerably better numbers on. This one was a small vendor placed job out in the Buffalo area. If you look here at the averages, and I should say the differences, pretty close. 2 pounds off, 3 pounds off, 1 pound off, 2 pounds off, really getting good numbers. And really, I thought what was interesting here is how close the standard deviation. When I'm talking about standard deviation, we're really taking a look at these 4 values of the static, rolling, static, transverse, and I'm sorry, rolling longitudinal, rolling transverse, static transverse, and static longitudinal, and kind of comparing them. All really, really tight. We didn't necessarily see this as much in the Utica job, but this was pretty telling to me. Another graphical look at where that data is. I find it funny on day 2 that the core was much higher than both the RDM and the gauge. So I don't have an answer for that. I think it's just one of those things. Maybe that core was a little wetter when we measured it. Not quite sure.
Kyle Thomas, we got a couple questions in the chat.
Sure. Do you want to read them?
Sure. How often did you do a puck test calibration of the RDM during the projects?
So we did the puck calibration early on, and then depending on if we had some changes or if we had some time on rain days, we would do another one during.
And then the next question, are there any time constraints between collecting field samples and fabricating pucks in the lab, i.e. within 24 hours, 1 week, etc.?
So we asked for, so that was part of the reason that we had it in the know. We asked to get this mix prior. And this is something that we're going to set up for our producers and our contractors again this year, because we put the note in the contract that they have to make these pucks ahead of time. These are typically commonly used mixes that they have off the shelf. So if they know that they're going to be working on a GPR project at the end of June and they're running mix early June, we'll work together. We'll have them make the mix ahead of time. We'll take those samples. We'll transport them back to advanced testing. Or in our case, as we get our system in shortly, we can test them as well and get those numbers. So we try to get that early on because I think that that's going to go a lot with educating the contractor and the fact that they're going to know, they're going to get meaningful feedback from the unit from day one. They don't have to worry about it going out after the fact.
That's it for now.
Great. So anyways, we did 2 passes down the road. The pink and green, I'm going to kind of try to keep the colors consistent. There's always going to be our center antenna. The red line that you're going to see is always going to be the longitudinal joint, and the dark blue is always going to be closest to the shoulder. This was another Region 5 data. This is out in our Buffalo area. The one thing that you'd see here is the pink and the green, which is our center sensor, is trending higher. There definitely is a bias. Going back to that picture of Christmas morning when everybody's ripping things open and nobody's reading the rules, the instructions, I should say, we didn't do a swerve test. We didn't necessarily see this bias right away. We saw similar results, probably worse results in the Utica project, our first one out. We didn't really necessarily know what was causing it. It was that arm issue. It was already referred to earlier in one of the earlier presentations. The slight variation of where those arms were sitting on the unit was causing a bias in the data. Route 97, this was another job. This was our third job, the last one we were able to get in the year. This was down in the Binghamton area. Really good. We were very tight. I don't have a lot of gauge readings on this particular day, but the one that I do have there, day one, lined up perfectly with both the core and the RDM results. Really, really happy with how this particular project showed in terms of accuracy. And you can see, I mean, a lot of times graphically, you can appreciate it, but in this case, looking at these standard deviations and these differences that you can see in the red box, really, really tight. I was really, really happy with what we saw. The only downside was generating this data in a format that you could read. Advanced testing would produce a lot of work for us and send us a lot of files, but it was still a lot of manual manipulation of the data in order to really see where we fell with some of this stuff. Even, the core data would leave, our core data that we would do as part of our normal QA testing, taking that in, getting that back in from a second or third source, bringing that in, matching it back up to the advanced testing data. This is what took some time, and you couldn't be distracted when you're going through this. So I guess my point is we didn't really know we were doing this well out on 97 until after the fact. A couple more of the longitudinal scans from this project where we have a high degree of confidence in the accuracy is we could really see an issue out on that shoulder joint. A lot of these roads, and I don't particularly remember the work history on this one, partial depth shoulders, or there's some issue out there out onto the edge. The density clearly lagged there, and it stayed consistent throughout the job. On 1015 here, you can see that we're starting to see that red line. It's actually more of an orange line down at the bottom, which is our longitudinal joint. We're picking up some low data or low density out there near the longitudinal. In 1021, we're seeing some significant drops in density out there. So this is data that we could get back right away to the contractor. They wouldn't necessarily, they would. They'd be able to get that feedback right away. I don't know if that conversation went on because I wasn't there during construction on this one, but still, we can go back. We can see what we kind of already intuitively know, that our lowest density spots are going to be out there at that longitudinal joint and at the shoulder's edge. I bring this back up, the data output, because this is something that we talk about with our EICs quite regularly. What the hell do I do with all this? What does all this mean? This is the data that we get from advanced. Now we have to make our decisions on how we roll it up and what we're going to do with it. We're getting tons and tons and tons of data. People want to know, what does it mean? Take some time to do that manual outputting, but so one of the things that we did with the manual outputting is, after we have all those rows and rows of data, we're trying to get a conversation about what's the spec going to look like. So I took some of that data and I basically just ran it through a normal distribution through Excel and let it define its own bin values. And we get nice normal distributions on there. I think at some point our specification is going to look something like this, where we're talking about statistically averaging all of that data. But what's interesting here is that this westbound sensor 9, you can see where everything, our peak bin, if you will, is in 142 to 145. The sensors on the outside, westbound sensor 7 is a little lower, and the one without a title, because I'm a bad presentation maker, the one without a title also is in that 137 range. Just so you know, that offset was also from the issue with the arms, the bias on the outside from the cart. Something else to look for, something else where it was caught. But I do think that this is something as an agency, I think we're going to have a spec that's going to look at some sort of statistical output or statistical analysis from all that data. So what I tell the guys is we're getting a ton of it. I'm not quite sure where our accuracy is yet. We have some really, really accurate data that we feel really comfortable with. And then we have some more that we just had some flyers on, and I really don't have a good explanation for it. So I said that Advanced did our testing for us last year. They bought the cart. They see some promise with the technology. We're also buying ours right now with the stick grant. The bid's getting open shortly. And this isn't a plug just because the MnDOT guys are on here today. This YouTube channel for the guys first going out, really, really good. Walks you through everything. It saves us. It's going to save us as an agency a lot of time because we don't have to make these training materials, and quite honestly, they won't be to this quality. 2021, I have a list of projects. Will be on the last slide, but we're really trying to identify what our accuracy issue is. Try to identify the limitations. We talked about something as heavy trafficked areas and the contractors turning around to pave back, match up in a lane, and we still got a guy pushing his cart twice up and down the roadway with traffic backing up. Little things like that. The last bullet on that side of the slide, which is the promotion, which is something that has been pretty successful because I think a lot of people are interested, but we have to keep going with it, is we have to show the technology off, not only to our producers, but our contractors and our regional people. Everybody's interested, but they still have to see it. They kind of have to feel it. They have to find something in the data to kind of justify it. So we're really trying to make an effort to make sure that we get projects throughout the region to get people familiar with it and get the contractors to believe that the data that's going to come out of this thing is going to be useful. I put in here that I'd love it that we'd have a pay item in for 2022. I don't think that's realistic. I think it's probably going to be another year as a pilot spec, not mainline or not standard usage, but I do think a pilot spec at 2023 is probably likely for us. And the reason that I even throw out a date is that I think that a lot of times when new technology comes out, people say, yeah, that's nice, and they kind of forget about it. If you tell them that this is actually coming and we're looking to making this as part of our acceptance procedure, all of a sudden everybody's ears pick up and they take this a little bit more seriously. So I think I have to put a date in to let people know that this isn't something that we're just playing around in the sandbox. So these are our projects for this year. We have that note in, I believe, 11 of them. 2 of them were carryovers from the previous year. I think Advance is picking up their own unit and second unit, I should say. So they'll have 2 units going around the state and we will have our own. So I think we'll have a lot more meaningful data. We'll definitely have a lot more quantity of data for next year, but that's pretty much where we're at. And that is my last slide. Thank you.
Great. Thank you, Tom's excellent presentation. So I do have a question for you. For those you showed on one slide the puck calibration. You have the 4 pucks deviate from the line.
Yes.
Are you aware? I know you don't know what's exactly going on. Do you think the water, the moisture in the puck may affect the rating? Because you showed all the 4 points on the one side of the lane is give you a high dielectric. So this making me think maybe there's the moisture, not the puck not dried, it totally dried it out. There's still moisture in there to.
I think that might be the case on some of the field pucks. I think that in the case of the lab pucks, that might have been more of a measurement with the calipers. And just like you said, a little bit of a difference there can cause a big question mark as far as the dielectric.
Yeah. Okay. Very good. Any more questions for Thomas?
Well, I saw one in the chat that I addressed a little bit, but I'd like to give Thomas a chance to answer. Robert from the FHWA asked, can an Excel macro be created to handle the input and analysis? Because you made a really good point about it's a beast to handle with the way it's exported, or at least it was at the time when you did those projects. And I'll address some of this afternoon with the improvements that have been made to the on-site software, but I just wanted to give you a chance to kind of expand on your experience with the amount of data and how you'd like to see it handled.
Yeah, I mean, I think it'd be great if we could come up with a macro. I think it'd be great if we would have agreement of how we're going to collect these things too, in kind of a set format to be able to do some of those things, because I think my eyesight definitely got worse looking at all this data and walking it through. So I think if we can come up to agreement as to what we want to compare and how we want to compare, then some of the things like building the macro in the background will just become that much easier of a fit.
Very good.
And I also just wanted to follow up that I think, Thomas and New York have been a really good example for all the agencies in the group of, they were not afraid to make mistakes. So they went out there and they took the technology, they kicked the tires, they collected some data. They forgot to do quality assurance on their data or were too excited to go out and collect, but they didn't throw the technology in the trash when they didn't get good results right away. And Thomas has been good to keep in constant communication. And I think it's just a good example for the group on how being proactive and continuing to learn by collecting and going out and getting data is a good way to get the technology to work for you.
No, thanks, guys. And you guys have been great. And no, we're good at making mistakes. So it comes naturally to us.
Yeah.
Thank you, Thomas.
Thank you, guys.
Yeah. So this brings us to a lunch break now. We're a little bit ahead of time, 7 minutes ahead of time. If I don't have any questions, then we can go to lunch break back by 12 o'clock. And then we can continue. Kyle will talk about the PaveScan 2.2 field software evaluation and the new features in the software. Okay, let's get a start. And I just want, before we start, Kyle, I just want to answer the question. Sorry, I didn't mark in the chat box. I'm also asked if those new features I talk about during my presentation will be included in the work plan. The answer is yes, they are included in the work plan, and the new released version will include these features. And Kyle will talk about this more specifically, those new features. And Kyle.
Thank you very much, Dai. Can you see my screen?
Yes.
Okay, good. Yeah, as Dai said, part of our pooled fund has been to advance the field collection and analysis software. As you heard from Thomas Kane in his presentation, it's a huge amount of data that we're collecting, and it's a bear to take all that data and make it into something that's meaningful, especially as you're collecting data on site. So we're going to touch upon 3 separate, I guess, categories of improvements that have been made in the field software. One addresses the issue Thomas talked about with a bias in the sensor popping up, and that would be what we're calling a quality assurance module. And I've had some discussion with Dennis Dvorak from FHWA, and probably technically speaking, it shouldn't be called quality assurance. It's more of a sensor check to make sure that your sensors are operating properly. And then there's also a new module to make sure we have quality measurements at the core locations. If we're going to validate our correlation to voids, we want to make sure that those measurements are especially careful and especially a special amount of care is taken to make sure they're of the highest quality. And then all three are big, but the one I'm most excited about is the on-site playback range filter. And this addresses what we were discussing in terms of being able to take all this data that's collected and make it easy to be able to tell the contractor or whoever's asking, maybe the project inspector, how's the compaction looking today? And that's what this playback range filter is designed to address. So let's start with what we're calling the quality assurance module in the software. But like I said, it's mostly designed to make sure your sensors are working correctly so you don't run into those situations where you've collected a lot of data and you have a problem with your validation that's caused by the sensor bias itself. So basically, the raw data you're collecting needs to be of the highest quality, and that's what this module is designed to test. And what you do when you use this new module is you just select quality assurance to let the software know that it's categorized as a quality assurance check data. And one feature with this is that you still can include it with your field analysis, but instead of having to try to wade your way through all the data to determine what's my quality assurance data, it's in a specific category as well. And we'll see that a little bit in more detail later. The three types of quality assurance checks that the software allows for right now is the high density polyethylene, which I don't currently recommend. It's a good kind of gross estimate on whether or not your sensors are working properly, but it doesn't represent asphalt pavement. So you're going to want to do, at least at the beginning and end each time you collect data, and we do it more often, is either a repeat line test where you take all three sensors and run it over the same line, or a swerve data collection with the idea that you're collecting a significant amount of the population of data and you should have similar results for the three different sensors. And again, you can include the swerve or repeat line data in with your field measurements as well. The main advantage, or one of the main advantages of this, is that you get a response right away. So this, when you go into your quality assurance module, it's actually going to pop up if the dielectric is 0.2 different than the population median, whether it's for the swerve test or the transverse line. And that's a huge deal because now all this data that's been collected with biased sensors can actually be either remedied, or as soon as possible, you can get to the vendor and tell them you have an out of spec sensor and you can do it with confidence. So the other aspect with the quality assurance module is that you actually can take the results of the test, and if you have, for example, a specific sensor that's consistently off by the same amount throughout the day, at least for research purposes, you can correct for that, and you can do it with a moving average or using the most recent one, similar to what a lot of states do with GMM measurements, where you're trying to track it throughout the day and make sure that it's updated. But again, we're not recommending to use the correction method. We're just using the output to say whether or not the sensors are in range or not. The way it's exported now, you can export just the quality assurance data only to, and an easy way to look at this is just to plot your dielectric corrections and make sure that those are no larger than 0.08, which is what we're recommending. And after getting the initial release, we gave some feedback that it would be also nice to get it to export the actual stationing location where these quality assurance checks happened in case you do get a flyer or you get a bias sensor. It's nice to know exactly where in the pavement that occurred. And that'll be available in the June release, whereas the quality assurance module right now is going to be in the April release without stationing in the export. We got a lot of feedback initially, and this is mostly from the 1.0 version of the RDM, where there was issues with antennas disconnecting and then lost data for an entire day. And now there's a system failure indication for both antenna disconnect, height out of range, as well as dielectric out of range. And the first and the third one seem to be, luckily, something that's in the past that was fixed with the 2.0 version of the software. But as Thomas said, the height out of range system failure indication comes into play when you flip your outside sensors out. Those wings had a tendency to sag, which can cause some faulty data. And that's been both fixed mechanically and then also with the software to tell you if you're having an issue with the height changing too much from when you did your metal plate calibration. And then again, with these things, the notification is set up so it pops up real time when you're collecting. And one thing we wanted them to put into this one is the ability to disable it if for whatever reason you're collecting data somewhere where you expect the data to be out of range, for example, on Portland cement concrete, or if your pavement is wet, which we don't recommend, but you just never know with research whether or not you can clearly define whether or not you want the data to just be thrown out. So that option is available, but for normal data collection, it's a good idea to keep it enabled. And then you'll also have the exported file indicating all the locations where the data was out of range. We talked about this a little bit this morning about the effect of the underlying layer on our measurement. So as most of you know, our measurement is based on the surface reflection, but if you have a thin enough lift and there's a difference in dielectric, such as a thin overlay on top of PCC, you can have an effect of the underlying layer. So the software has been improved to do a better search to make sure you're only selecting the first high amplitude reflection. And actually, this has been part of the RDM2 system since the beginning, and the initial trials have looked good, but it is of interest for the various states. And in addition to the Auburn NCAT study, we're also doing a study at Minroad to hopefully give a little bit more quantitative response to you guys on when exactly this system can be used for thin lifts. And again, this is an improvement that was made with the software to try to mitigate the need, but it's our job as the pooled fund to evaluate whether or not that's actually doing what it's supposed to, and then the limits of when it is not applicable to give us a accurate density. So with the height of the antenna relative to the surface, you get an indication here, and this is really important for debugging purposes. So if you do start to get an issue with your sensor, you have both this height of the antenna that's exported, and again, this is something that was very useful when Minnesota and Ohio and New York had the issue with the sagging arms. We were able to catch it relatively early and make a correction, both, as I said, mechanically and then also with the software. And in general, I think this is a good time to mention that a lot of these improvements, especially with testing the quality of the dielectric, are designed to give you as real-time as possible a result and as much confidence as possible to be able to say, this system is not working the way it's supposed to, because trust me, the vendors would prefer you to tell them that their system is not working properly sooner rather than later. So please, when you go out there with the system, even if it's you missed something that was obvious, that's the best kind of fix to do. But if something's off with your system, please give us a call or give the vendor a call and try to debug to get your system back up and running the way it's supposed to. The reflection quality metric is actually something new that's supposed to help us if there's some ambient noise, such as at a cell tower. And this is outputted as a signal quality that's typically close to 100. But as you see here, if you go close to a cell tower, that signal quality measure starts to drop. And this might be something that we're going to want to monitor to make sure that we're identifying these locations where we have too much ambient noise to be able to get an accurate dielectric measurement. And that's currently implemented in the new version of the software. The next general direction where there is an improvement with the software is with the validation core locations. And what we're trying to accomplish with our cores is to make sure that that correlation we develop between our dielectric measurement from the DPS in the lab and what we use to convert that to actual air voids is good. And so that's why it's important to get a very accurate dielectric measurement, and then also make sure you're cataloging correctly the exact location of the core, and then most importantly, getting quality data at that core. And this distance, what I'm calling a hybrid mode, is what we're currently recommending, where you have basically the best of both worlds. Before, we had been doing static measurements directly over the core, or distance controlled measurements leading up to and past the core. And Ohio and Alaska and Minnesota and maybe some other states saw better results for whatever reason with the distance mode. But the issue with that is that you're taking measurements off of the core location. So with this hybrid, you start basically at the diameter one end of the core, and then it's still distance controlled, but it's just at a much higher frequency. So when you collect across that 6-inch diameter core, you're getting multiple measurements to make sure you get a really highly accurate dielectric at that core location. And the other nice part about this software is that you get that readout again right away based on which sensor you're actually using at the core. The other nice part about this software is the ability to preload core locations. So as we explained last year in Minnesota, we basically just piggybacked on the locations that were already selected for quality assurance coring. However, to be able to do that, we had to pre-run our random core locations based on assumed tonnage and start and stop stations. And the goal with this portion of the software is basically to allow the user to input a file that alerts the user when they're within a certain distance, let's say 100 feet of the upcoming quality assurance core. And this helps with the data collection process to make sure you're not missing any of those quality assurance core locations, and you can get a nice accurate static measurement at the location that's going to be cored after paving that day. And one thing just to think about, you don't have to answer now, is based on your experience collecting, about approximately when you'd like to get that alert. I think GSSI, we put in half the length of the previous pass, with the idea being that you'd stop your pass if you're before halfway through to do your core measurement. But now I'm leaning more towards just a static within 100 feet or something of that nature, in case you have a short previous pass or a really long previous pass, just to simplify everything. But one thing to think about as a group is when we'd like to get an alert that we're coming up to a core location to help us complete our data collection in the most efficient way. Another nice feature with the core validation is that, similar to the quality assurance, it's a completely separate set. So you get a live display of all your core locations with all the corresponding information. And as soon as you have a % voids result for each of those core locations, then you can go into the actual software and input it. And the other part is you can actually export the results to Excel, and this comes in very handy to be able to just take the dielectric and percent voids and directly copy and paste them into your location where you did your puck calibration or your puck correlation with voids to see if it's actually proving the accuracy or inaccuracy of your correlation. So the big red X here is basically to transition us away from trying to write macros on a knee. This was a macro that we wrote at MnDOT for the 1.0 system, and it was pretty effective for what it did, but it required a lot of steps and required a very specific format of the data, which, as you know, we didn't at that time have a standardized format of data, and basically any sort of improvement was required a lot of different steps just from a compatibility point of view. So we really wanted to transition away from these macro type analyses to being able to do it directly on site. And that's task 9 of our contract with the vendor, which is to basically figure out a way to present the results in a concise manner that can be digested by the road builder, or really whoever wants to know how the compaction is going out there when you're collecting the data. And the general direction we're going with this is what's called a playback range filter. And this does all those filtering operations that we did with our MATLAB macro, except it does it on site, and it does it in a way that's, I think, much more organized. So you can, as of right now, let's start with what you can do. You can say, I want to filter by a certain start and end station, and you can filter it based on your lot or sublots determined for your cores. You can filter it by your lift. You can filter it by your sensors. If, for example, you have a faulty sensor that you don't want to bias your data, and you can filter it by your lateral offset, which is basically your distance from the center line joint. We're also planning for the June release to be able to differentiate mat and joint data and combine those all into one data set. And we'll get into more details what's required to accomplish that, and hopefully get some feedback from the group. And then also there's a bug with the exclude, but the purpose of the exclude portion is if you have a bridge deck or some sort of a section that or exception in your project that you want to exclude from the data so it doesn't affect your other measurements. So in order to accomplish this, we're going to get into a little bit of details now about how we need to organize the data. And the reason I'm bringing this up with the group here is we want something that's going to work for all the different agencies and states and federal highway on how we actually handle our data. And one of those things is after you go into your other info button, which is a new button to be able to do this project level filtering, is to define our lanes. So currently right now we just say, what are you using as your reference line, and then how far to the left or right of that reference line you are. With the June release, the plan is to be able to actually define our lane extents, which is so your lane number, and then you say, where is your left edge, where is your right edge, and those are defined still where they are relative to the reference line looking up station, and then also the ability to say whether your joint is confined, unconfined, or other. And other, you might use that if it's changing throughout the project consistently, and you want to use a different means to be able to determine whether it's confined or unconfined or some other kind of joint. So once you have that, then we have the opportunity when we go into our report options, which is going to be a new feature in the June release. And we can really start to break things down based on percent within limits and medians and output histograms, and we can do that for both joint and mat compaction, which most states differentiate in terms of how they evaluate the compaction of the placed mat. And with this, again, you're going to have to go into your other info button within the file. So we already did that within the project level. And now when we go into the file level, here's where we can separate our data similar to what we do with our cores. And every state does it slightly different, where you basically section it into lots and do your analysis on a lot by lot basis. And once we have that, now we can, both in the upper right, we have information we need to create histograms or to easily plot station versus percent within limits of the joint or percent within limits of the mat. And doing this, it requires the user to say, okay, what's my acceptable upper limit for my mat and what's my acceptable lower limit? And this is something that once you predefine these things, you have a pretty simple, easily plottable export. That's kind of the goal of these improvements. And a little bit of the motivation for this, I thought Craig Landefeld from Ohio DOT, who's been really active and done a lot of great work with the density profiling systems. He separated his RDM data or his DPS data into lots and did a direct comparison with the cores. And I think this was a great way to be able to show off the ability of the continuous coverage technology as it compares to cores when you're looking at it apple to apples on a lot by lot basis. And then of course, once you dive down into each individual lot, now you're looking at 40,000 data points for every 1 or 2 data points from the core. So as a group, I think we need to consider what we want to export and something that's easily digestible for this type of summary analysis within PaveScan. And one thing to mention here is that we asked for summary analysis for export, but the vendor's considering also including that as a display within PaveScan, which I think even something simple like median percent voids or whatever it may be might be a good way to be able to give that on-site feedback that we're hoping to give real time. One additional feature that I did want to mention, and we'll go into more detail on this later, is that it wasn't part of the pooled fund, but a couple vendors have actually made their data so that it's compatible for import into Veda. And again, we'll talk about that more later. I just wanted to also mention that as an additional improvement with the software capabilities. So I'll actually be presenting the next topic too, and I'd like to give us time to have discussion on some of the more big picture things. So I think I'll jump right into the example project here. To keep us on time and allow us enough time to really have good discussion with each other. So basically, the purpose here is to take these new features and show you guys what it actually does for you with real data. So we're going to start with what the module again is called the quality assurance check, but really what it's doing is trying to make sure your sensors are working properly. And this is where I'm going to look at it from the lens of a single day, August 18th, that we collected on Highway 30 in Minnesota. And I'm going to use that data to explain what each of these features are doing for us. And then I'll take some data from other states that they've sent me, as well as some other projects that we've done at MnDOT to kind of explain some of the more extreme cases of why we do these different things with our on-site software. So what you see here is the real-time dielectrics, and what's nice about this is you can see right away that they're all within a reasonable limit of each other. We're hoping that they're all within 0.08 of the global median, and you can feel warm and fuzzy about your system and your data collection when you see something like this with your first swerve test or line test of the day. And this is also exported in terms of difference from the global median on an on-site measurements tab that you can get to. And this will all be part of our videos that we create for all these updates that we're planning on releasing in May. So the other thing you can do with this export is once you're done with your data quality tests for the day, you can easily export it and just show where they are relative to your acceptable line. And this is the results from this Highway 30 August 18th paving example, where you can see, okay, maybe there was a little bit of bias with sensor 181 where it was a little high, and a little bit of bias with sensor 171. But at those magnitudes, you're really happy with that no matter which sensor is on that spot on the pavement, it's giving you a good, accurate result. And this is a good way of cataloging the quality of your sensors as well. But as we said, I'm also going to give some examples of why we have these different on-site responses. So as Thomas mentioned in his presentation, on their project, their initial project, while they were still kicking the tires and excited to get out there, they were seeing a bias with one of their sensors. So and they didn't end up doing the quality assurance test, but I took one of their locations where the left and right sensor were both 2 feet on each side of the longitudinal joint, but still had a 0.3 different dielectric. So it wasn't a swerve test, and maybe the right sensor actually was 0.3 lower than the left based on the mat itself, but probably not. And I use this as an example to say, okay, Thomas would have went out there, or whoever was collecting the data, and they would have got a pop-up that says data quality is out of range, would have saved some of the trouble with going through with the validations with the cores and the Newt gauge and finding it out that way. This is something where you can get that feedback as soon as you perform this sensor validation testing. So, and the other thing, as I mentioned earlier, is what it does is gives you the confidence to call the vendor and report it. And maybe it's something simple. Maybe you just have to recalibrate with the metal plate, but it really can save you a big headache. And one thing I'll mention here is Ohio had a similar issue, and they have collected tons of data, quality data with this system. So in their case, it's not just a matter of getting out there and not doing all the things you're supposed to do. This is something where the vendor actually is looking at their sensors and making sure that the sensors they have are of the utmost quality. And that's another thing I'll mention is that I think I alluded to it a little bit earlier, but the vendor does want to know, and really all the vendors want to know when their systems aren't doing what they're supposed to do. So please don't hesitate to assume that you did something wrong. You don't have to assume that you did something wrong. It could be the equipment itself, and the ability to fix it really depends on how early you can report and try to debug what the issue is. And that's something that I would just encourage all the states to do. Minnesota, when we first took out the new 2.0 system, I was, like I said, ready to throw it in the trash. The data quality was not great, and we reported it to the vendor, and it turned out we had been given the wrong temperature calibration. And in this case, getting that information to the vendor right away allowed us to collect the entire season from there on out with very high quality data. But again, the goal is to have everybody to be able to have that sort of a feedback and a pop-up telling you, okay, your data quality is out of range, you need to do something different or report it to the vendor. And the nice part about this is if you think it's just a flyer, you can also actually easily separate your swerve or line test data because it's now cataloged as a quality assurance data. And you can see here sensor 171 is consistently higher than the other sensors. And this is something that's a telltale sign, even when you're on site, that you have a faulty sensor. So this is the same exact export that we showed for Highway 30, just a higher scale because the sensors were more out of range, where you can see just this simple export of all the different correction factors for the different sensor numbers shows you the issue you're having with a bias in your sensor. And that's something that is just directly output as part of the new software package. But I feel like I'm focusing too much on the instances where the software is bad. The fact is, once we got our temperature correction, we ran over 60 miles of swerve testing, and very few percentage of the time did we see any of the sensors acting outside of the 0.08 acceptable range. 93% for sensor 171, 96% was within range for 173, and 94% were within range for 181. So the key is to be able to catch these flyers when your sensors are not working within range, and that's kind of the goal with this quality assurance module. So North Dakota also sent us some data, and I was able to look at it, and they so far, from what I've seen from them, have a really good quality of data coming in with their system. So on North Dakota 1, the one swerve test that I was able to extract from their data saw the medians within 0.04 of the population, which is well within range, which is nice because then when you map their full width result, it makes sense having the lower density, and you can trust it being a lower density along the edge of the pavement there. And I suspect at the beginning, maybe being the start of the paving day where we typically see lower density. We also looked at North Dakota's Route 36 data, and again saw really good results showing the quality of their sensors on that project, including a really long swerve. And then I also wanted to show an example where, because they did do the down and back swerve where they had different sensors on the different side of the pavement, even though it looks like on the right side of the pavement they had some lower spots there, the swerve still was able to detect that the sensors were working properly. And then when you actually map along that edge where it was low, you see the low density. And again, these sort of trends are only possible to see when your sensors are unbiased, and that's what we're doing with this quality assurance check. So for the 18th paving example, we also wanted to show how you actually load that correlation from dielectric to voids into the software. And so if you remember from the PUC 2.0 kit, we had this Excel template where we have a relationship between dielectric and percent max density, and we get these coefficients that basically tell us what dielectric or what percent max density or percent GMM corresponds to each dielectric value. So the new software, well, this has been implemented for a while now, allows you to do, we're recommending a linear fit for either whether it's percent compaction or percent voids, or even newt gauge density, to use this sort of fit based on these coefficients to relate your dielectric to air voids. And you can catalog these based on the day and route, or however you want to remember the different days of paving, and these can be called back as you process the data, and we'll see that a little bit later. So
Kyle,
yeah, yep.
Kyle, there is a question in the chat box. Does the temperature affect the sensor calibration?
Okay, this is a great question. So when we say temperature, when we're talking about temperature calibration files, such as the example where we saw poor data quality coming from our sensors the first time we took RDM2 out, that is actually a internal vendor parameter where basically we're looking for such high precision measurements that they have to calibrate how their system is responding as the internal components of their sensor heats up and cools up. So they do extensive testing with a heat lamp at various temperatures to make sure that they lock in that specific sensor to their internal temperature components. In our case, we had a temperature correction for a different sensor that was being called by the actual sensor we had out in the field. So because we had a different temperature calibration file, that's what was causing the bias in our data. So the big picture is that we didn't know what was causing the bias in our data. We just were able to report it to the vendor that there is a bias. Now it's up to them to explain to you why. So that's the temperature that I'm talking about with the sensors being out of range, the temperature of the internal components of the sensor. The temperature of the mat itself, in terms of its effect on dielectric, there's been multiple studies that show, and our experience has shown, that within the range up to maybe 150 degrees Fahrenheit, the variation in dielectric is very minimal, which is, as you know, if you've looked into any sort of IC data or seismic data, is much different than what you see there, where the stiffness of the mix is directly tied to the temperature. What we're measuring is dielectric, which is insensitive to the temperature fluctuations that you might see out in the field. So that's a really good question. I hope I answered it for you. Is there any other questions, Di?
Not yet, not so far.
Okay. Yeah. So with our core measurements check, we also have that same real-time table, which is nice because now you have all the information associated. So you input your core ID, the station it's located, the lateral offset, and now you, as soon as you have the percent voids result, you have your validation data point. And this can also be exported, which is important because now it's as simple as taking a copy and paste back into your Excel file. So if you remember, we had pasted down here in the lower left our puck results to create our correlation. Now we can paste our core results to determine if our correlation is good or not. And in this case now, when we're looking at, when we're looking at our relationship between the blue line, which is our relationship that's created based on the pucks, we can compare that to what we're seeing with the cores, which are these gray dots. And what you see here is that, generally speaking, if you look at the difference from predicted versus actually measured, we're within 1% voids here for the majority of these core validation positions until we get down here closer to the end, where we have upwards of 2% higher than predicted. And so that, this is just color coded that if it's over 1.2% different, we color code it red because that gives us an indication that, these data points here are not accurately reflected by our prediction. So looking at the data here, there actually was a change in mix that didn't trigger another correlation or a creation of another correlation because it was only a 3% change. So one working theory here as to what caused those couple data points to move off the line is this difference in dielectric properties of this Northwood half-inch rock versus the Glenville half-inch rock is actually what caused the need for the recalibration. So because of observations like this, what we're planning on doing for this next construction season, especially considering now that we have our Puck 2.0 kit that we can just keep right in that contractor's lab, is just shoot for dielectric of all of the samples that are fabricated throughout the day. And the nice part about that is they have to fabricate those samples every 1,000 tons anyway in Minnesota, and the different states have similar procedures. So we might as well get a dielectric value and monitor it and see exactly, instead of trying to guess what type of changes in the mix are going to cause a shift in our curve, we can actually just measure it. And I suspect if we start measuring this and other states start measuring this, we'll find that this dielectric check might be a pretty good quality check on the mix itself. So that is to say, if there's no reported change in the mix, but you see a spike or a decrease in your dielectric, that could be a good indicator that something with your mix is changing, whether it's a wet aggregate source or whatever it is. So anyway, I gave this example because it speaks to the importance of having a good handle for what exactly causes a change in our relationship between dielectric and air voids. And with this new puck kit, I think we're in a good spot to be able to just monitor this, not just day by day like what we've done in this Highway 2 example, but sample by sample. And this is just an example we've given before where you see a shift in the relationship when you swapped out limestone for granite. And so that's basically just a reminder that you really want to pay special attention to changes in your aggregate source as you're trying to monitor whether or not you need to recalibrate your device. And what I was talking about earlier is not necessarily filling in this full range of voids. You probably want to do that at the beginning and the end of each project, but maybe just monitoring the puck down here at your design voids and making sure that that's not shifting left or right as an indicator that your calibration is okay. So this brings us into the more fun part, in my opinion. So what we've done so far is made sure our raw data that we're measuring is of high enough quality, and our correlation from dielectric to voids or percent compaction is of high enough quality. Once you have that, really what you have with this technology is a continuous assessment of the placed relative compaction of your mat, and you have it real time right behind the final roller. So I wanted to start just by refreshing you what you get with the typical analysis file by file. So this is just a location where the joint measurement on the left side of the joint was pretty low, down around 89% compaction here. And just exporting this data, you get also a defect corresponding to this location between station 92 and station 93 that gives you a nice indication that what I ended up using, and I'll show it in more detail later, is anything that's less than 88% relative compaction for 10 feet or longer. I told the software to export it as a red line out to our Google Earth image. And this is still something you can get with your file by file analysis. But any of you who've used this software, it's very hard to just go file by file when somebody asks you, something happened at station 225 plus 30. Can you look up what's the DPS telling me there? It's not really well set up until now to be able to answer that question. And that's where this playback range is really critical and I think a really powerful tool. So this right here is actually showing that full 3 miles of data that were collected on August 18th on Highway 30. And it's separated into left mat, which is the left lane mat, left lane joint, right lane mat, and right lane joint data. And you have your scatter plot showing your relative compaction versus station here for all 4 of those categories. And this was able to be done just by selecting those specific offsets in our playback range. So we're going to play with this a little bit and just show you what you can kind of get. So the first thing that jumped out at me from this day was that we were doing really bad on our right joint. So that's this green data here, where it's getting so bad at 120 plus 00 that we're approaching like 87% voids down there. And that got me thinking, well, how's my calibration looking? So first thing I did is, okay, so I looked to see where were the cores taken that day. So on this project, there were only 2 cores taken at the joint, and they were taken in this area of the data. So let's take a look at that. So by zooming it in on the stationing corresponding to the one of the cores, which is at 172 plus 00, we saw 89.47 value corresponding to the DPS measurement, and the core result showing up at 90.1%. So obviously one of the better spots for that section of pavement. And then also at station 175, we got a 91.3 on the other side, which corresponded again to one of the better spots of the pavement. So these are the only cores we have for the entire day on that joint. And again, to refresh your memory, there were lots of different locations that were significantly lower on that project, but that's basically what we're stuck with our current coring procedure. So once we see that, then we can go back to our calibration and just remember that we do have dielectrics and percent max density results there, so we can feel pretty confident in our correlation at that point. So now moving forward, this is just a geospatial view of after we take that filtered data for the full 3 miles, you can export all of the data and see the low spots just by looking at the blue, which corresponds to the less than 88% density, or you can just export what's called defects, which is can be set by the user. What we ended up doing on this one is set it at 88% or less percent compaction, and it's got to occur for 10 feet or more to make sure it's a real defect. And this, even in a zoomed out 3 mile view, you can see the sections of your pavement where you're really struggling, and these ended up being predominantly or almost exclusively at the joint in most locations. So now we can kind of break it down. This is that same data set, except just looking at from 91% to, or from station 91 to station 92, get an idea where our mean dielectrics are, but then also look at some of these really low spots here in more detail. And this is something that I suspect as we move forward with this technology, we're going to be able to have a pretty good reason for why these sorts of extremely low spots occur. And I hope that we can use this technology to stop those reasonings from happening anymore. This also shows the middle portion where, again, you have another low spot here at station 120. Would be really interesting to see what was going on with the paving there. And then, of course, you still have this histogram, which is just a count of occurrence at these different density levels where our left side of the, or our right side of the joint was significantly lower than both the left side of the joint as well as our mat for both of those lanes. And then this is the upper approximate mile of the pavement. Again, seeing really low density on that right side of the joint. And this, again, I'm kind of harping on it quite a bit, but this really points to the importance of doing your quality of your dielectric check, because if you have a biased sensor, you could see a distribution like this that's not actually showing you lower density, it's just showing you a biased sensor. So when we see something like this and we have properly checked sensors and we have properly validated correlations, we can tell a lot about the pavement when we're looking at this data here to see where the deficient spots are. This is another example showing if you just output what you see in black is within 8 inches of the joint, and then the blue is 2.5 feet away from the joint. And the reason I exported this to show to the group is that you really see what look to be kind of noisy trends when you look at it at a 3 mile width here. But in fact, when you zoom in on these areas, they're legitimate changes in the density that's being observed by this technology. So it's a really powerful way to see how your mat is changing in compaction at multiple offsets due to various construction practices and maybe some underlying layer effects. And with this playback range, to me, this defect export becomes really powerful too, because now you can see beyond a reasonable doubt if, for example, a contractor or inspector saying, "Oh, I noticed something around station 210 through 217. Can you let me know how I'm doing?" Well, you can export your defects, in this case defined as 88% or less for 10 feet or more, and see a real clear indication of where you're failing with your density. And ideally, you can catch this sort of stuff early enough so that you change your practices so it's not happening anymore for the rest of your project. This is an example just to expand upon. So now we're switching away from 30 and back to 251. And Dr. Leva gave a good introduction to this, where we had a project where the contractor did great on their density. They were up above 90% on the majority of the project. But for whatever reason, the stationing from 390 through around 400, there was an extreme drop in our density here. And another interesting feature of this type of technology is you can really see local drops even within this generally deficient area, where some places it's all right, where the core happened to be taken, and some places it's a lot worse. And this kind of speaks to the importance of not just taking small samples and assuming they're representative of the pavement, and really not even assuming that you have a nice normal distribution. In this case, you're just as likely to get a 92% core as you are to get a 96% core. And that's where that random chance comes in with the cores. It'd be nice to use this technology to really fill in the gaps there in our knowledge of how the paving is going. And I think kind of one of the last ways that this technology really ties in to help us improve our practices when we start to compare it with the other intelligent construction technologies. So we further evaluated that drop in compaction that occurred around station 390 and saw it corresponded 1-to-1 with a drop in pass counts, vibrated pass counts, as well as the temperature of the mix when the breakdown roller hit it. So this type of information, in my opinion, is really promising in that there's a reason when you have deficiency of your compaction. And with this technology, as opposed to cores, you can actually identify those drops in a way where we can compare it with other technology to find that reason and correct it moving forward. So here's another example at 395 within that stretch, where you basically didn't have any more than one pass with a vibratory roller there. And of course, you're going to see a drop in your density associated when something like that happens with your construction practices.
Kyle, there's a question
in
the chair box. So in geospatial view, the software overlays the results over the old pavement. While the results should be displayed on the new pavement, is it possible to improve the display? This is a little bit confusing to see good compaction over a pavement or cracks.
True. Yeah. And with the KML files, it's just overlaying it on top of, whatever the most recent aerial footage was in Google Earth, because the export of those defect locations or even the data is just directly imported into Google Earth. And it would be interesting to see, if there was a way to get a good comparison with more up to date. Although I will say it is kind of interesting if you look at some of these deficient locations, it's a little bit informative to see some of the, even in some spots, I don't know if I exported one where it was almost like it was rubbleized in 2017. So in some states, by seeing the 2017 image here, you might have a little more insight about what's causing this deficient spot. But yeah, it's a good comment. I don't necessarily have an answer on how to accomplish that.
So maybe we can look at these design files. Maybe we can overlap under this
Yeah.
design file.
Yeah, that's another thing I should mention is that we're exporting design files into Google Earth too. And that helps us when we're exporting these defect locations because the pictures aren't actually geospatially all that accurate. So you shouldn't look at the pictures to say where you are within the lane even. But these alignment files are very accurately created. So if you have these alignment files, you have a line exactly where the joint was supposed to be, as well as where the extents of both of the lanes are supposed to be, which is really nice because you can see here, this one corresponds directly to the kind of shoulder edge deficiency, and this line here corresponds directly to a center line joint. So that kind of concludes the, I guess, features that are either released in April or June as part of the software, but I also wanted to take this opportunity to talk to the group about what they'd like to see moving forward and to kind of generate a little bit of discussion. And I'll pass it to Dai here because he's got some ideas too. Once I'm done with this, is looking at ways to do a little bit more in terms of the geospatial data. So what Professor Barnes at the University of Minnesota did as part of a MnDOT project currently separate from the pooled fund was to take this swerve geospatial data and actually create a rectangle out of it and space it into the various 1 foot spacings along the lane width. And basically take this data and make it full lane width compatible in the sense that all the data that's within a foot of the joint is categorized together, within 2 feet, 2 to 3 feet, and so on all the way across the joint. And what's nice about this data set is you can really take this data that you can look at visually and see these sort of trends where it's lower along the outside.
Oh, you're not sharing screen. Sorry, Kyle. Are you sharing
Okay.
screen? Oh yeah. Okay. Sorry. It's coming. Yeah. Sorry.
It's coming. Okay.
Yeah.
Okay. Good. Thank you.
Somehow didn't show mine.
Okay. So, and you can get a real quantitative view even with this data that's not cataloged as the exact different locations along the joint, but use the accurately mapped data to get a quantitative analysis of how the center of the lane is performing compared to the outside of the lane. So that might be one direction that the group may be interested in, is figuring out a way to get these geospatial filters implemented either into the vendor software or a third-party software that would be able to do these sort of analyses. And with that, I'm going to pass it to Dr. Dai here to discuss some additional analysis needs.
Kyle, there's a question.
Yep.
Is there a recommended sampling frequency that can be set in RDM2?
Ooh, okay. So it's the default, I believe, is set at 1/2 of a foot, and I keep it at the default for that. And one thing that I would mention here is that everything that you can change as a user is not actually affecting the frequency that the data is collected. The only thing that would change the frequency that the data is actually collected is if you switch from walk to fast walk to vehicle mode, because that's actually affecting how often it collects. But if you change your frequency within the software, it's just affecting your display. So you should be in good shape either way, but I just like to keep it at the 1/2 foot analysis in terms of what I'm seeing real time. I will say, related to that, in terms of processing large amounts of data, especially like that 3-mile section that I showed you, I changed it to 1 foot spacing for what you report and then 3 foot spacing for what the moving average is used. And I found that to be a good way to have a happy medium between smoothing out the data, which you get when you have a larger moving average, and catching the local variations in the asphalt compaction. And the other factor there is the larger you go with your output interval, the quicker the analysis is going to be. So you could even increase from that foot to maybe 5 feet if you want a more quick and dirty analysis of a very large station range.
Okay, can everybody see my screen now? Yep. Okay, good. Okay, so I just want to throw out a few thoughts out here and then generate the discussion from you and see if any another data analysis you want to see for this from this pool fund study. Like Kyle mentioned about, we have not official contract yet with the Professor Barnes, and he's a statistical professor at the University of Minnesota. He's willing to look at the data for us. So we give him a 2-day worth of the data and Triangle 2 and just ask them to tell us something, if any is interesting to you. And he's very familiar with our DPS system. He knows how do we collect the data. So we'll give him some 2-day worth of the data, and he look at that. One thing Kyle mentioned about is this part calibration. So from laboratory part calibration, we generate this blue line, this straight line. It fits very well. We got 6 pucks in here. So if we do the field core validation, ideally, if everything perfectly, this gray dots is the field core measurements and should be lined up very well with this blue line. But for some reason, and something happens in the field, it's not always going to be lined up with this blue line. So sometimes you will see the bias on the one side of this blue line. So in this case, we got the constantly lower Dasher constant on one side of this lane, just like the Thomas showed this morning, and he got the 4 pucks on one side of the calibration curve. So like this case, we need some criteria to say how far away from this blue lane is bad. The cores are bad, and so maybe we need to look at the recalibration. Maybe the mix is changing in the field. So we need some type of the criteria to make a determination whether or not this calibration is good or bad. And do we need to move this calibration, or do we need to redo this calibration for that material? So this is one thing we're looking at right now. Another thing he pointed out to us is I think I found it very interesting is this variogram. So he did a statistical analysis on this 2 days worth of data, and he plotted this variogram, and he pointed this to ours, and there's 2 good features in this plot. One is this intercept with the y-axis, and this is called the nuggets. So what does it mean? This, you can see these are 3 sensor measurements, and this point, the intercept from all these 3 sensors are very close. And what does it mean? This means the system variation. So with this, the x-axis is the separation distance. So without the separation distance, which means this point indicates the system variation. So if this is the 3 values are very close, then which means the system or the 3 sensors are more or less similar, acting similar, which is good. Another parameter he pointed out to us is this correlation length. So when you see on this one sensor reach the asymptotic after some point, so this distance that causes correlation distance, correlation length. So for this case is the 6 meter, close to 6 meter. So what does this mean? This means that what he explained to us, and from our understanding, is within this 6 meter longitudinal direction, and the material are very similar. So, which means if you select 2 points, just a point A and a point B in this within this 6 meter range, and if you know the density at the point A, then you can reasonably estimate the density at the point B using the density from point A. So there is a similarity in terms, in our case, in terms of compaction or density within the 6 meter. This for this specific project. So I think these features we need to look at further. We need to get more statistical analysis from these professionals to extract the physical information from our measurements, and hopefully we can incorporate into the actual spec. So another feature, and he pointed to us, is distribution. If this is again, just 2 day worth of data, and he just look at the center 1 feet of that line, the data. So if you look at distribution of that within that feet, within that 1 feet center part of the line, and you plotted the data, and he found out the data is close to distribution, is close to the logistic distribution. It's not a perfect normal distribution. And if the sensor, if the data follow the perfect normal logistic distribution, should be follow this perfect dashed line. But we had a little bit of deviate. So it's not perfect normal logistic distribution, but it's close. It's nearly follows the logistic distribution. But one feature we do not understand is this non-tail in here at the low dash constant range value. So we don't know what this mean. What does this mean? And this on all the sensor from all the 3 sensor data. If we put all the 3 sensor data together, but if you look at individual ones, the sensor 173 is very close to the logistic distribution. It's a little bit deviated, but not too much from deviate from this logistic distribution. And same thing for cell 8 for sensor 181, it's also close to this normal logistic distribution. But if you look at sensor 171, so all this non-tail data at the low dash constant value, they all come from this sensor 171. And this is something we do not understand now yet. And I would think maybe it's due to the sensor acting like this, or maybe the sensor is close to the joint, or maybe the sensor just did not work well, and another project maybe on and off works well. So that's something we're looking at. How do we effectively to identify some error data from sensors? So I just wanted through this is some ideas we're thinking to pursue further. So I want to, like Carl said, I want to hear from you. Anything you want to include in this profile? Any inputs?
So I think to summarize some of the additional proposed improvements, the one I presented at the end of mine was more geared towards being able to filter the data based on geospatial characteristics of it. And Dai presented an idea to look at the data statistically to make sure it's of quality. So that would be something that could be done on top of what we're doing with our quality assurance module, where if you throw the sensor data into the statistical model that Professor Barnes could create, it would give us an indication that an additional indication on whether or not there's an issue with our sensors. Are there any other ideas, or do we just want time to chew on those ideas? And while you're thinking, I did see that Kevin Clethermus had a comment. I want to understand what Kyle's talking about sensors. How do you deal with a vendor when you are paving and you notice a concern with the data sensors? That's a really good comment, Kevin. It's something that for when we're researching the technology is a much different issue than when we're deploying the technology. And I think that's what you're getting at, where if this technology gets deployed as a performance measure of compaction, we need to have a plan of attack for if a sensor is out of range or not working properly. And I think, well, two things are going to have to happen. One, there's going to have to be enough stock of the equipment itself, so that in situations like that, maybe there's a agreement where you are able to swap out a bad sensor in a short time frame. I'm guessing initially for deployment, there'll have to be something in the contract to be able to fall back to cores if something like that were to occur. But it's definitely something that this group needs to start talking about in terms of how do we handle it if there's a sensor that's out of spec, or if you need to replace technology. And I know with thermal and some other intelligent construction technology, just having enough stock and a quick turnaround time from vendors is a critical aspect for that.
Yeah, Kyle. And the thing is, when is the sensor out of range? You know, that is the question. Yeah. Or like the inspector.
Yeah, and that's part of our 0.08 is currently recommended for two reasons. One, it appears to be achievable a high percentage of the time if your technology is working correctly. And then also it corresponds to a less than 1% variation in air voids, which is an acceptable performance in terms of precision. But it's really great to have Professor Leva on board. You heard from him earlier today, and I think he'll go a long way. And his experience in NCAT as an entity, I think they'll be really helpful in helping us get a little bit more insight on that question.
So kind of that's why we're trying this pilot program this summer to let the contractor directly contact the vendor to either rent or buy the program. We just want to try how that's going to work out with directly between the contract and the vendor. Like you mentioned about if the sensor is totally out in the field for data collection, and they directly talk to the vendor and see how quickly they can replace it, or maybe just a simple recalibration stuff like that can be done. So in this way, I think it can encourage the vendor to also promote them to maybe get more sensor build up, stockpile them by themselves.
The other question, guys, what are the other sensor companies coming around with? Are they coming and presenting new ideas with you, or are we just still kind of with GSI expanding it right now?
Well, from what I understand, there's two, and there are some multiple vendors out there. But from what I know, Sensors Software and Earth Science, they're also producing similar equipment. I mentioned this at last week's the Federal Highway 101 workshop, and also, but we are for this profile study, we are using the JSSI equipment. I mean, we worked with from them from beginning. And
yeah, and that's what I'm asking is maybe other states are getting calls from other vendors.
They maybe, yeah.
Maybe, has anybody had that to date?
The geoscience and the earth science and the sensor software to produce similar equipment, yes, they do.
Yeah, I think what Kevin is asking is, have any of other states been approached? So Minnesota, our experiences, we've collected with both sensors and software, and Chuck Oden with Earth Science Systems has been very active. We've collected data with, I think they're going through Humboldt for their system, and we've tried their system out and had numerous discussions with them. But have any of the other states or entities had any contact with the other vendors to date?
I'm wondering, are other people muted? That they're not speaking?
I'm muted, but I don't know what they're in this.
They can unmute.
Okay.
Yeah.
New York has not had any contact with any other vendors.
Thanks, Thomas.
Yeah, I mean, we in the Mobile Asphalt Technology Center, we've had, when we were still on travel, we had some other vendors that visited, and our team had a look at them just in that respect. But I don't know whether Steve can give an update or if Hoda Azari's on, but they, as Steve mentioned, they did look at Turner Fairbank and a couple of different devices. So, but I can't really report out on that.
And I think ranked different aspects of them, if I remember correctly. I think they
Correct.
each gave a webinar, and then Turner Fairbank gave
Yeah,
another.
I mean, there was a report by the Federal Highway, and in terms of evaluation results of these different vendors' equipment.
Another one that I just spoke to, 3D Radar, is they have at least, I don't know if you'd call it a beta version, but they have a software that they're trialing to be able to export dielectric that they're planning on implementing as a module for the 3D radar system. And one thing to mention is that it is ground penetrating radar technology. It's very specific to get an accurate surface dielectric, but there are multiple GPR vendors. So that's encouraging if, for example, this gets to the point where the data suggests we can deploy this stuff nationwide. I do believe that there's the manpower to be able to start producing these things, and that's what makes it really important to have our quality checks of the systems in place, because in order for it to work, they have to be able to collect very precise dielectric measurements.
So in our roadmap, would you have a thing down the way here of comparing multiple systems at one point?
I thought the Hoda, maybe, have you looked at the different equipment too?
Yeah, Hoda just gave a long, good comment there. Yep. And there will be, as Steve mentioned, a roadmap meeting later this month, which might also help provide some clarity for the questions you're asking. We've been on schedule all meeting, so I'm going to try to get into the next session, which is scheduled to start at 1:15, which is big picture analysis. So let's go into that now. And Kurt Turgeon was going to present this for MnDOT, but he's at a cabin somewhere with no internet connection, so he entrusted me to present some of the slides he sent. So I'll do that now. Let me show my screen and open Kurt's presentation. Kurt gave me some slides that give an indication on how Minnesota is looking big picture with DPS and how it fits in with other technologies and quality assurance in general of the placed pavement. And this is actually data that we collected way back in 2016 that he wanted to bring back up because it speaks to the importance of being able to compare it with other technologies. So I'm going to maximize my screen here and sorry. So these histograms were initially the way that we were always looking at the data, looking at both the mat, which is in blue and red, and then the joint, which is in green and yellow. And what we are going to look at here is specifically the mat. And what we're looking at here is a shift where we had a local increase in dielectric. At that time, we were just outputting dielectric, not a fully calibrated percent voids when we added the fifth roller. However, that eventually dropped, and we never really explained why until Kurt started digging into the ICT technology and didn't really see an immediate reason as to why we would have seen a drop like that. And I'll spare you all the details to try to keep this on schedule here. But basically, eventually, through mining the data, found out that there was a much significantly lower mat temperature for rollers 4 and 5 in the area in question. And what happened over those 15 minutes was a water break. So basically that just speaks to kind of the importance of not just looking at one technology or another, but seeing how they fit together holistically when trying to really stamp out these issues and identify construction-wise how we can get our best uniformity and high compaction of our placed asphalt pavement. So again, this just shows more details about this going to get water 15 minutes that corresponded to that drop in density that we saw with the DPS back in 2016, and then leading back up to the increase that we saw when they added the roller initially. Kurt wanted to touch on some of the stuff we're doing with thermal because it all ties in with the placed map. They have a pattern recognition to find poor construction based on thermal, as well as a geospatial data analysis to recognize these patterns. And my understanding is they're mostly based on geospatial uniformity to the point where we now have incentives and disincentives based on limiting these poor practice as measured by the thermal. He gave a couple examples here. One of them, I think they're both highlighting what we're trying to do as an agency, which is eliminate poor practice. And one of them showed that the breakdown roller was not keeping pace with the paver, and the contractor was instructed to fix the process. And as a response to this, the contractor provided another roller and presumably improved the pavement. And this type of information in the past wouldn't have been available to be able to make that sort of improvement. Another problem that I'm sure everybody has is the saturated stockpiles and segregation and trying to get a thermally uniform mat. And there was in one case where they basically just decided to switch states because they don't have thermal over there, was the quote that Kurt gave. And this is some of what's going on right now, which is basically thermal and intelligent construction roller data. There's a lot of neat things within the Veda software to be able to compare and analyze data with these technologies. And now we're just starting to be able to import, coming June, dielectric data or DPS data into Veda. So what you see here is some of the fields that the DPS data provides. Of course, you have your air voids, dielectric, and density, but then you can also provide some of these arterial fields like the speed of the DPS. And I could see signal quality and things of that nature being a good thing to import into something like Veda, where we have kind of a holistic view of all the different technologies. Another thing that Kurt showed here when they're just evaluating this Veda technology with DPS data we provided. This is from that same Highway 30 project, where we saw the low density around stations 111 and 112, and you see it here in Veda as well, but then also the ability to overlay the core location. So here's a 90.5% compaction core located at a spot where the DPS technology was indicating around 90.5% compaction. So it's a pretty powerful tool that MnDOT is definitely invested in and uses extensively. And I think we just wanted to share it with the other states, just so you're aware of some of the power of this type of an analysis suite, and discuss some of the needs moving forward. So we're getting DPS data into Veda. The idea is to try to automate some of the more geospatial analysis that's going on with thermal currently, and do similar things with DPS. We'd like to be able to compare them to each other. I thought that might be of interest to all the different states to be able to say, the way I look at it, the DPS says, okay, what's my resulting density profile? And then you can look at this other ICT technology to say, okay, what actually was going on that caused that problem and really try to use this information to eliminate those problems before they occur. And one big thing that Kurt capitalized, and I fully agree with, is for this to be something that's useful for DPS, it needs to be real time, because I believe that the real-time nature of the results with the density profiling system is where the real game changer is in terms of being able to improve our construction practices. And that's something that is currently being looked at by the pooled fund that's currently housed in the National Road Research Alliance. And I just point you to Kurt or Rebecca, actually. She's obviously really active in that area, and the Advanced Materials Technology Group does a great job with all these new technologies at MnDOT. So I would encourage you to talk to them and maybe generate some discussion today about how VEDA might fit in with the needs of the different states of the DPS pooled fund. So with that, I wanted to pass it to Craig, and I don't know if I kind of just told Craig last minute that we'd love to hear his thoughts on big picture DPS, because he's been so active and done a great job with the technology, as well as some of the other intelligent construction technologies. So I just asked him if he was willing to give about 5-minute update on where Ohio is, and you can share your screen if you want, Craig, or just update us verbally.
Thanks, Kyle. I didn't put any slides together, so I'll just give a few items here, and if anybody has any questions or whatever, happy to get into that. But I guess a little bit of background, for us here at ODOT, we typically buy about 5 million tons of hot mix every year. We're operating on a preservation budget that's about $650 million a year, with probably another roughly 200 million per year that's coming into our major rehab program, where we're doing major work, reconstruction of pavements. So when we look at the dollars that we're spending statewide, we're into this, repair costs we think are costing us somewhere in the neighborhood of $30 million annually, and a year of service life for us is somewhere in the $50-60 million a year range, we think. So those are the kind of numbers that we're thinking about, and we're saying at our office, boy, if we could add one more year of life to our pavements, we could save $50 million maybe. Boy, if we could reduce repair costs out there, we could save by half. We could save $15 million. And as we look through our pavement management data and just field experience and things that we have, most of the things that come and bite us, that cause us issues, are just built-in defects. And we made a mistake. We didn't recognize it during construction. It got built in, and then now fast forward 7, 8, 10 years down the road, and we got a problem. And some of them are big and some of them are little. And one of the easiest ones we noticed, and I'm sure most states are in the same boat as us, everybody's moved towards joint density specifications or some sort of joint specification. If we look at, say, our some of our general system routes where we use less stable mixes, higher AC contents, less angularity. We don't have those joint issues. They're on our 12.5 millimeters. They're on our little dryer mixes that we're putting out on the interstates and stuff like that to get stability out of them. So we're trying to always strike this balance, and we think we've improved quality there, and we think that has given us some confidence that now we think we got this joint issue under control. It's better. So we keep thinking, okay, so how can we get more value out of our pavements? And we think that this construction end is a big deal. We think that's where the most value can be brought in. We think that, improved data, timely data is the key. We got to be able to reduce defects. We got to be able to measure it more effectively. And quite honestly, we want to raise our standards. We want to raise the bar for our contractors. But if we don't have a way to measure it, if we don't give them ways to, measure their processes and how they're doing, we're not going to be successful. And I think just about everybody would agree if you had to pick one, metric, density is kind of king, right? So, you can have maybe even a marginal mix. If you get pretty good density on it, it'll probably perform pretty well. So, as long as we can, get good density out on the road, and measure it, we feel real confident. That's why we like this technology so much, because it's allowing us to, measure hopefully the density, or at least a correlation with it, and get a really good picture of what we got out there on the road. Some other things I think about, I'm sure other states are in the same boat we are, but staffing isn't getting any better. We're way down on staff. The experience and knowledge of our staff is almost gone. We've not been able to maintain a lot of that. We've used and relied on more consultants, so that experience doesn't come back into our organization. And we're looking at our field staff who, with our current specifications, we're relying on them to be the keeper of quality out there, right? They have to recognize these issues. They have to speak up. They have to, bring it up to the contractor. They have to raise it up, because our sampling and testing won't flesh it out. Taking 10 cores a day is not going to flesh out if we've got cyclic segregation or something like that. That's where these technologies start to come in, and we're relying on our staff to do that. And quite honestly, we're not doing a good job. Even the best of them, we could have some improvement. So, we look at those, we say, how can we improve that? Well, we think these technologies are the way that, we can do that, because it allows us to measure a really high percentage of the pavement and then recognize and control some of these defects rather than relying on staff to recognize them. We can actually measure it and control them. All that's kind of leading up to with us, we've been doing a lot of research into, some longer life pavements, HIMA binders, balanced mix design. We cement treat almost all of our subgrades anytime we can. So when we did a research project a few years back that basically concluded that we think we can build a perpetual pavement structurally using about 9 inches of hot mix with a highly modified binder and a cement treated subgrade. And that's a huge deal for us, because that is very much economical when we compare it to what we build some of our more traditional build-ups. And we're looking at that and saying, boy, this is kind of exciting. We're actually just getting ready to implement a project to build one in the field and measure strains in the field. Everything else has been, an accelerated facility. So we look at that and we say, wow, if we can build something like that, this could be a game changer on, some of our, our highest volume sections would maybe have 9 or 10 inches of hot mix on them. And we say, boy, if we're going to capitalize on this, we have to be able to build quality pavements, right? Because if we go out there and spend a little extra money, or even think that we're gonna exceed the push these lives out, we got to build them well. And if we don't build them well, we're going to fail. So that's where a lot of this push is coming from our end. And I think everyone sees kind of how these pieces fit together, right? It's like if you got IR for laydown, I see that personally as more of a QC effort. It's going to take some effort on our part to get it there, and force contractors to use it more. But using the thermal, we feel like if we can lay it down without segregating it, if we can use the IC on the rollers to map coverage and make sure we get good compactive effort, and then use this technology like the RDM, where we're using, measuring a high percentage of the pavement we put down, we can raise that bar, and we think we can eliminate a lot of these defects. And the last key to me has been getting some sort of software like Veda or some sort of way. Veda seems like the most logical tool to me. That's why we were kind of pushing it. But we need that software to be able to manage big data efficiently. Again, we don't have big staff. We got to figure out a way to do that and have some of the stuff more automated to where you're not getting in Excel spreadsheets with 20,000 lines of data in them and stuff like that, and trying to manage a project by these kind of things. You have to have the software to support it. So it's taken a while for these things to come together, but that's kind of big picture what I see. I really think if we can use these technologies to improve construction quality, that we're going to reap big benefits, and that's going to allow us to do some of these other things. So.
That's great stuff, Craig. Does anybody have any questions for Craig about kind of the ODOT big picture that he just laid out?
Hey, Craig, Steve here. With everything you said, you talked about remediation. Were you thinking you're in a better position now to ask for remediation while the project's still in that construction mode where it's not closed out yet? I mean, you definitely are going to have a better aid to answer dispute resolution.
What we're hoping, Steve, is that by using some of these technologies, and don't get me wrong, none of these things are fully implemented in Ohio. I mean, this is kind of more where we'd like to go, not where we are today. But I personally think even if we aren't to the point where we could say, on the fly, we're going to fix stuff, right? I mean, that's still going to be challenging. RDM it still has to, you have to wait till it got rolled, right? But yeah, it might on the acceptance decision, but hopefully before that, we just recognize something today and we don't do it tomorrow, and or we stop doing it in a few hours, right? So we just really shrink down the amount of issues that we see on projects is kind of how I see it. I don't know if I see people putting them on rollers and talking about adding compactive effort maybe, and maybe some of that stuff comes along someday, but I'd be happy if we could just shrink down the amount of time that we're putting down defective stuff or having issues, recognize them sooner. I don't know if that answers your question, Steve, or not, but
yeah, it does.
Yeah, that's exactly the type of things we need to continue to discuss as a group. Craig, thanks a lot for that. Thomas also has called me up a few times, and he was asking some really good questions about big picture related things, standardization of data, all that good stuff. And I wanted to give him 5 minutes or so to give, maybe ask some questions, give a little big picture perspective in New York.
Thanks, Kyle. I kind of just want to say ditto to everything that Craig just said. He really hit on a lot of the same things that we're going through, and a lot of the positives that we see with the technology. And one other add-on to that piece of the conversation, Steve, we just had a project last year, which was not an RDM, which was several miles of paving in the Adirondacks, which had a particularly long haul time. And there was visual segregation after the fact, but there was passing density results based on where our course fell. So this technology would have given us a way more complete picture as to what we need to do for that level of remediation, as opposed to the disputes that we're now in. So yes, so that's a definite. I also think the other thing that Craig mentioned is the lack of people right now that we have and the lack of experience. And this offers us a real quantitative form of analysis. It's not just a guy taking tickets who's going to be gone the next day. It's not a guy who may or may not be operating the gauge correctly. It's going to be able to put a number on things, and everybody can much more easily wrap their heads around that. So to that point, some of that data management piece, and I think Kyle brought it up, or maybe Di brought it up. yes, everything has to be accurate, which is all the work that you're doing right now, and we're nothing if we're not accurate, but we also need to be able to start thinking about how we would implement this into a specification. I go back to the ProVal software a lot. It's a standalone product that I can run on my laptop, on my desktop. I can manipulate the data a couple different ways. I can get outputs of the values. I can break them down in a number of ways. Right now, I'm really dependent on the GSSI software. I understand moving to Veda. I haven't personally played with it enough to really have that feel or have a lot of relevant commentary about it. But that ability to get that data out to a project at the end of the day, they're used to getting core numbers. If we can give them your 70% in this range on coverage or your 20% range on this coverage, we haven't even discussed, at least internally to the state, what our roll-ups will be. Are these going to be 50-foot sections, 10-foot sections? Yes, we're collecting on every 6 inches, but is there going to be a standard? Should there be a standard of what is our smallest unit of average? So it's a lot of those things that now that we've had a year to kind of collect things and kind of start finding out what we don't know, those are the things that we're really trying to hopefully get answers for in the next year or two.
Yeah, really good stuff, Thomas. Thank you. Any questions for Thomas about New York's big picture?
Kyle, it's Glenn.
Hey, Glenn.
How
you have the floor, Glenn. Outstanding.
Okay, just a comment based upon the last 2 speakers. Both Ohio and New York mentioned issues with number and I'll dare say quality of people in the field. And I wonder how we can address that through this effort at all. Is there anything we need to do special to make it easier, make it simpler to use, you name it? It just seems like, I know Minnesota has the same issue, and I think it's a nationwide problem. So maybe that's beyond this, but it is important. We want to create a product that's not just accurate, but is also easy to use and valuable to everybody involved. So just throwing it out there, Kyle.
It's a great point, Glenn. And I think we touched on that a little bit with initially Thomas's presentation, where it's kind of a double-edged sword where you're collecting all this data, which is powerful and great. But if you're just exporting it to a huge spreadsheet and asking somebody to look at that and make any sense out of it, it's a big task, and you're creating more of a need for expertise. And I think that's where, whether it's a specific vendor software and hopefully multiple vendor softwares or a third party like Veda, we really got to put our heads together and say, okay, what's the bare minimum that I run this test, I press this button, I generate a report that I can give to somebody and they can get some useful information about how they're doing with their compaction. And, this is something we're taking our best guess at, and it evolves as you collect more data, what is the most effective. But we really got to be a team in this, in the sense of saying, in Alaska, we want this, or in Ohio, we want this, or, and really put our heads together and figure out what this is that is going to be automated and then digestible for people out in the field. Yeah,
and it's one thing for us to create a product that is usable in the field as best we can, and another thing to create a product that maybe is used centrally and information is distributed back to the districts. I know Rebecca's group does that somewhat now with our IC program, but I think it's important to think about long term as we work through all this.
Yeah.
Well, Kyle showed one screen right now. in the new release, there will be a feature in the software can export the data to the VIDA. So there is the one feature in the new a new release. So that may be good for those states has the VIDA program to try out, and I show them layout with core locations, core results. And they can get the instantaneous results for the feedback to the field people.
Yeah, I think getting VEDA to be a real-time cloud-based software, and I also think about how, you know, not just thermal and intelligent construction, but also some of this e-ticketing type stuff, they all fit together. I mean, for us, we want to know when the trucks are dumping and when the next truck is going to be out there, because we need to monitor that for our, if there's a change in mix, we want to know exactly what station that change occurs at. And I do think, as Craig kind of said, these all tie hand in hand. It's just a question of, as a group, how do we approach it so that we can extract all this powerful information and do it with the resources we have in terms of personnel and expertise.
Kyle, this is Craig. You know, I'm just sitting here thinking that, you know, as you move forward with some of this stuff, I mean, you gotta, I think, keep kind of two hats, you know, and part of it is just, you know, boy, I'd like more, I like better, I like higher, but at some point you got to then start to say, okay, now what's practical? What can I really do?
Mm-hmm.
You know, we don't have PhDs on construction sites. You know, data analysis, things have to be straightforward. They have to be relatively simple, feasible, right? You know, you can't have some quality control test that, you know, requires this super complex procedure to go through, right? I mean, things got to be straightforward and simple. And kind of to Glenn's point, I think we got to think about that. And he also gets I'm glad he turned his monitor on, because he gets the coolest office I've seen on any so far, a wood shop. So that's awesome. So.
Craig, that brings up a good point, and it's, at what point is the technology good enough to go out and try it and let the vendors develop the advancements in the technology?
Mm-hmm.
Yeah, I mean, I guess in my opinion, you know, we have to be satisfied enough that we're accurately paying a contractor, right? I mean, we don't want to have things where one person on one side of the contract is just inadvertently getting the monkey put to them because of something that we didn't think of or we didn't notice. So as long as we have those kind of controls and we're satisfied with that, yeah. But like you're talking about, Kevin, you know, maybe you can. You don't have to have everything on your wish list accomplished, probably, to make some steps forward.
Mm-hmm.
Yeah, and I think that's it. It's getting it out there, and Kyle mentioned it too. There's a lot of GPR radars out there, and if they start seeing you using the technology, that's a big push for people and contractors to say, I need this. And that's going to advance the technology more than maybe just isolated groups that, like we're talking about, maybe 2 or 3 other vendors right now that are working on it. And how do we share that information with them? And maybe that's how do we get out to the bigger vendors?
Yeah, I'm hearing a lot of great comments, and I'm thinking, you know, to put it on 2 extremes, we want it to be as simple as possible, but on the other hand, we don't want to take that technology out there, find a deficient density spot, pay the contractor less, or ding them for it, and then they come back and tell us, okay, let's take a core there, and it turns out we had a sensor that was biased. So I think we're walking a tightrope here in terms of, on the one hand, not trying to be too sophisticated with the technology to the point where we can't physically collect the data the way we need to collect it. But also, we got to make sure that data that we're collecting, we can stand behind. And it's something that if we get questioned on it, we have done all the necessary checks to make sure it's of the quality that it needs to be. And some of this stuff right now is not deployable. You can't walk behind with a cart for 15 miles back and forth for all your projects. It's more proving concepts and figuring out, okay, first let's figure out how do we make the technology work the way it needs to work. Once we get that figured out, okay, maybe we got to put it on a gator with a movable bracket, or maybe we got to do a robot, or whatever it ends up being. And I do understand that a lot of times this starts to move to pie in the sky instead of, okay, what do we have right now and how do we make it implementable as is? And I do think, Craig put it really well. You got to have two hats on, and I think having people like Craig and having this group talk about it and discuss it, I think we'll hopefully be able to walk that tightrope the right way. We've been on schedule the whole meeting, and we haven't got the states to give updates yet, and I don't want to miss that. So, Di, can you lead the last portion of our?
Yeah. So I just want to give a comment on Kevin's comments about getting a big vendor involved, and there are big vendors. I mean, we got them involved in the beginning of the DPA's study. We invite them come here, like Census Software and Earth Science and the Peer Exchange a couple of times a few years ago, and also the talk about the TRB meeting. So they're very aware of our this DPA's pool fund study as well too, and also this technology. So I think they're moving advanced technology by themselves now. Steve also talked about maybe later this year or early of next year, we should get some user group meetings, and also invite this vendors join this user group meetings and talk about, give them chance to present the progress on the equipment development. So in terms of the last item in today's meeting is the state's updates. I want to go to the main first. I know Dale Peabody, and he made the comments in the chat box. And Dale, are you still there?
Yes, I'm here, Di. Okay,
thank you. And do you want to give a little update on?
Just real quick, where we are, we did receive the 2.0 version last fall, and it was, I think, kind of late in the game, so we were not able to get out on the road with it. So this year, right now, we have one fairly large project on the interstate, 11 miles. It's a mill and fill, 1.5 inch surface. It's a gap graded rubber mix that we're going to get out on as much as possible. And that project also has the paver mounted, the thermal profiler. So we're going to have that data, and we'll do the lab calibration, the core calibration, do that comparison on it. In addition, we're working with UNH, as some others are, on their study that's looking at using dielectric for the bulk specific gravity. So we hope to run a bunch of tests for that as well to collect some data for UNH. And that's all we have for now. Hopefully we can pick up other projects. A lot of our, as Ulrich mentioned, a lot of our paving is, we have a handful of mill and fills and a handful of inch and a quarters, and then it's all less than 1 inch. So we'll do what we can to get out on projects and hopefully collect some good data on those.
So you'll be wanting the results of the thin lifts as soon as possible, then, it sounds like.
Yeah, I think so. That would be helpful.
Okay.
So are you planning to collect data by yourself, or are you going to planning to maybe hire somebody or contract to collect data?
No, it will be us. It will be, you know, a GPR crew or Ulrich. And I know I think Rick was still on the line, and Ulrich, I don't know if you want to add anything.
You have anything, Ulrich?
I think I will let Rick to talk.
Okay. Yeah, this is Rick Bradbury. Great discussion today. Appreciate all the good work and good information sharing. No, you know, Dale just hit on something that probably is our biggest challenge is just got a small crew. We've had our non-destructive testing team who's done some of the data collection, but they also run our FWD, our high-speed GPR. They run one of our ARAN units. So just you know, the fact that our research engineer and assistant research engineer are out collecting data on projects gives you a picture of where we're at with that. So one of the things we're still looking at, you know, it's great that we're still collecting information, but a lot with this and thermal profiling, we feel that those two tools are the biggest bang for the buck as far as advancing pavement quality, and we're still working with our industry, although slowly, because they seem hesitant to change anything that is not specified to implement tools such as this, even though all the data we collect shows that their thermal profiles have a lot of paver stops and a lot of thermal segregation, even when they're using an MTB. So we see these tools as being very important. We have a very good quality assurance program from the point of view of sampling and testing our materials. This construction piece is really, I think it's going to be a game changer. I still think that accuracy will be great correlating the RDM to density, but using just the dielectric and measuring uniformity is going to be very valuable because quality is inversely proportional to variability, and out of the box, these things can, as long as it's working and functioning properly and not defective, it is measuring uniformity. So as a QC tool, I think you can go out without even comparing it to a single lab compacted specimen or core specimen and get a great deal of value out of improving construction processes by reducing variability.
It's a great point, Rich.
Yeah, it's a great point, and that's the advantage of this device. And the core cannot give you any, uniformity measurements. Give you density, but doesn't tell you the uniformity of compaction. This device can give you density and also uniformity, and that's a big advantage of this device. I only have a few minutes left. I want to give all the states the opportunity to talk. On Idaho. Anybody from Idaho? Mark? Okay, Maryland. Maryland, anybody from Maryland? Okay, Mississippi. Mississippi? Nobody from Mississippi either? Wow. Missouri.
Everybody's shy, Di.
Please speak out. Don't shine. We're doing, like I said in the beginning, I do need your feedback and input to the project, and your involvement is very important too for us to make success for these specs. Anybody from Missouri? Okay, the New York already talked, and the Maine talked, Ohio talked, Pennsylvania. All right. Anybody? Pennsylvania? No. Washington?
Yeah, I'm here from Washington.
I got one.
We don't really have anything new to report or update. We're still waiting to get new staff in order to take this out in the field and try it. But this has been very interesting to hear all you guys' experience and knowledge so far today.
Thank you, Carl.
Sorry, this is Pennsylvania. I was having trouble getting unmuted.
Oh, sorry.
Anyhow, yeah, we're kind of in the same category as kind of like thinking in a larger sense like Ohio is. We want to support this kind of research and this kind of pooled fund. We haven't done any projects yet, but we're trying to change that. We don't have a real large research group, and we did a few projects early on with the roller, the roller technology, and I kind of got overwhelmed with the data and stuff and kind of pulled back on that. But we see this as something that we can use to do a lot of forensic type of things and show us where we're doing, where we can improve our specifications in a grander sense. I think that the IR, the thermal stuff has a lot of potential, not only just from the thermal segregation part, but the just simple GPS, knowing where you are on the road and where you had a problem, and then using this to come in on a forensic basis and tell you, what your problems are, would be a pretty nice tool to show. Okay, here's where our problems are. Let's do some things to fix them, and work with the industry that way. But yeah, the data and the people we have, we just can't handle it. That kind of thing. Right.
Great, thank you, Neil. The North Dakota.
Yeah, this is John Stork. I'm in materials and research in North Dakota. So I'll just try and be brief on our experience with this, but we were able to get out and collect a few projects during the 2020 construction, as previously stated. The collections themselves are mostly just to, I don't want to call them proof of concept, but to become comfortable with the actual technology itself, and the RDM unit and the data collection. Similar to other states, it's more of a staffing concern than anything, because as you know, it's labor intensive to collect these projects. And all of that is basically done in our research section with a few different people. So we did get the lab kit, and we were able to run the samples that we collected during those projects in the summer, and we ran them over the winter and then created the lab correlations and compared those against the projects. For the most part, the lab correlations fit really well with themselves, but we did have a bunch of flyer cores in the actual field mix. And similar to New York, we had a lot of longitudinal joint that didn't fit anywhere. They didn't seem to really have a correlation at all. But I think a lot of that was due to basically inexperience on our end with some of the collection aspect of it. So this year we basically have bid some additional cores, and we're hoping to do a few intensive data collection projects where we can sort of vet out the technology a little bit farther, and then also figure out how significant of a mix change is required to actually, trigger a lab correlation, and sort of balance the constructability versus, getting good data. Yeah, so that's pretty much where we're at in North Dakota.
Great, thank you. Utah. Last one is Utah.
Yeah,
no, Kane's here.
Yeah, this is Ken from Utah. We've just purchased our RDM 2.0, and just looking forward to getting it out on the street, taking it for a spin around the block and see what we can do to it and learn from it and just get used to it. Basically, that's where we're at.
Good, thank you. That's all I have. Thank you for the updates for the participant states. And also, I should ask the Federal Highway, anything, Steve, from you? From anybody from Federal Highway?
Well, I didn't know if Hoda was still on the call, but Turner Fairbank or Leslie, if you have anything to add. Sounds like no.
Okay.
So we're all set.
Okay, that would be good. Any further or more questions for us or for the presenters? Okay, if no, and that's end of our meeting. It's 3 minutes past 2, and we consider as on time. Or 3 minutes.
We were on time until the very end,
Yeah, thank you, everyone. Thank you for participating in this meeting. And like I said, keep continuously get involved in the project and give us feedback. And that's very important for us to revise these procedures and produce these videos. Once it will allow the travel, I still don't know what's the guidance on the travel and the meeting. Then we wish to bring the states back here in Minnesota to let you see the Gator DPAs, and hopefully we'll have the robot DPAs ready in this year, late this year or early of next year. That's all I have. And any closing comments from Glenn and Jeff?
No, just thanks everybody. Appreciate everybody's hard work. Like what I always say with this new technology, let's not hold it to a higher standard than our existing technology. You know, we trust one core every so often, and I don't know. So just keep that in mind. So thanks. Appreciate everybody.
Yep. Thank you all.
Day.
Thanks, everyone.
Yeah, thank you.
Hopefully we can meet in person at some point here.
Yeah.